So what actually happened yesterday was our total session went for more than 3 hours, 3 hours 5 minutes to be exact. So Google Drive does not render videos that are bigger than 3 hours in some cases. So I tried changing encodings. Even I looked for it, but I never found anything. But I thought that there were past sessions which went for more than 3 hours, and they were like quite successful when I added it to to the drive and people watched it. But it didn't happen yesterday. So then I tried splitting the video file into half. It took like 3.5 hours, 2 to 3 failed attempts on Windows machine because the the native photo app keep actually crashing. So then I finally switched to WSL Ubuntu, used FFmpeg, and then split the video enough and then uploaded it. After 15 odd minutes, the video started rendering. And till that time, I actually quickly hacked my way through into a system, uploaded to Vimeo, and created a front end. So I was actually planning to wrap it up today and share it with you guys if that Google Drive wala thing wouldn't have worked. But that has worked. So I'll just try to basically polish the framework, just adding a bit of security to the platform that only one IP address can access it at the same time and all. So I'll just try to add that basic security checks and we'll send you all an invite to that so that you can stream it into various resolutions, basically not just HD, but starting from 360 to 1080, so that if you are on mobile internet, you can just basically lower down the resolution if needed. So for that, I'll be hosting it on Vimeo for now. See if I can find something.
Yeah,
Fine.
Kapit, once while we have some time, so
Yeah.
do you mind describing what happened to Unacademy during the hack? I mean, what was the root cause?
Someone got access to our AWS account.
AWS? What?
AWS account.
Okay. Okay.
So someone got the access keys and secrets from a hacked machine. So basically someone's machine got hacked, and from that, access and secret keys were leaked. That access keys and secret keys had a lot of permissions, had a lot of privileges on AWS, and then that user tried to misuse everything. He or she created a lot of a lot of dummy IAM users and started taking destructive actions on our infrastructure. So although we had some great policies set up around that, but uh, you know we could not prevent data leak. So that data got leaked, unfortunately.
Okay. So somewhat similar to Twitter. Twitter also, I believe, somebody's account got hacked, and I mean the system got hacked, and then
Mostly that's what happens. With respect to infrastructure, there are a lot of strict policies that are anyway applied. What is not protected is typically the access keys and secret keys that resides on the office laptop, which are there in the home folder or .aws folder. And obviously the path is fixed. And since the path, obviously everyone knows what the path is. If due to any Trojan that got placed on an employee's machine having a privileged AWS access, everything is gone.
okay.
Just curious, was it a Windows machine?
Nah, nah, Mac. It was Mac. So we all thought if it's a Unix-based thing, why do we need antivirus and all? After the incident, we realized why do we need an antivirus even for a Mac machine?
So what was I mean after actions? What did you guys do?
I did not sleep for 3 days straight. I rotated me and couple of others. So we three were involved in this because at that time our team strength was only 12. So me and couple of other folks had a lot of idea. Had almost all the idea about infrastructure. So we rotated the entire infrastructure, every single EC2 instance, every single AWS Lambda, every single thing, every single code base message secret was removed. And obviously every single secret was rotated. Every single instance was rotated. Database passwords were changed. We took a major downtime of an hour during at around 6 p.m. to rotate all the databases. We just put our entire website and app under maintenance, and then took that plunge and like just got rid of it. Yeah, 3 days were horrible, and it happened on my birthday, 13th May. It happened, and then I didn't sleep for 3 days straight. And the worst part was that was just the beginning of the lockdown. So that was the first time when we were all working remotely. If we were in office, it would have been much easier to communicate. And at the time, we had like literally 24 hours long Zoom call were there. मतलब we were just chatting कि अरे ये हो गया rotate वो हो गया rotate. Did we save this thing? Did we rotate this thing? Everyone was just trying to recall what all exists on our infrastructure. We had about 700 odd machines that needed rotation. Uh, 20 odd databases whose password needs to be changed. On each database, there are approximately 40 users. Dot goes the password of those got changed. And what else? Baki code base where say entry was removed. We implemented VPN. I specifically implemented VPN within 15 minutes. Like I was just googling how to do it, how to do it, and just set up AWS VPN within 15. Within 15 minutes, I did set up that VPN and all. Then what all we did? A lot of drives to do. Matlab, it was right. Matlab, it was basically once in a lifetime experience, but it just opened up ki, okay, we have to do so many things. So let's ensure that security always comes first. And we obviously learned it the hard way.
Okay. Yeah, thanks for sharing. Yeah.
A lot of great learnings there. Matlab, actually, it was after this when when people realize that yeah, we do need a dedicated SRE team. And now since Arpit knows infrastructure a lot, let's make him manager of it. So that's how I transitioned into an EM role, leading the entire SRE vertical.
So, but your all the systems are what running on Kubernetes or something, or
Yeah, then we started our migration. So we use a very flaky setup of Kubernetes at first, but then once I became basically there was no one sole brain behind infrastructure. It was like whoever wants to use whatever, we're going to use it. But then once I started owning up SRE, I started defining how we should be doing it. So then for the first couple of months, I hired a team, I did set up the entire team, and then we worked upon building uh, a great in-class Kubernetes setup with security first in mind. So once that was there, then we started offboarding service from our legacy Kubernetes to this newer one, migrated services that were running on EC2 instances to this Kubernetes one. Approximately 90% of our infrastructure is natively running on Kubernetes, and every single microservice that spins up or by default spins up on Kubernetes unless they have a very strong argument on running it on EC2.
okay, and cost wise, what did you lose again?
Cost wise,
On,
during security
on
thing.
yeah, no, on Kubernetes, running on Kubernetes versus running plain.
Yeah, it's running fine with respect to cost. Obviously, it does incur a little extra, but it's worth it. The kind of management capabilities it gives us, that's unparalleled. So that's a good
Great,
decision.
great.
Chalo. Let's jump into the second part of database series. So, Smith,
Is it just me or
what happened, Srisha? Disha might be reconnected. Chalo. Session is recording. Chalo. Let's start with database NoSQLs. So today, आज का system design would be really interesting one. मतलब we'll be discovering some really interesting design choices and how can we scale a certain thing and मतलब exactly how. And obviously, this is again not a mythical animal, something I built and scaled and I've seen working in production handling great traffic. Okay, so we'll start with understanding NoSQL. We'll answer some really hard questions during the span. Acha, by the way, I went through the couple of feedbacks that were given to me on yesterday's thing. So thank you for the positive ones. And one suggestion that was given was let's take break after 1.5 hours because second half is going for 2 hours. typically that is not planned. I took a break around 5, expecting it to get over at 6, but our discussions go really long. It's fun to do so. I'm more than happy to do it. I'll try to actually find a great midpoint according to the things that are planned. Right? Sure. NoSQL. Almost everyone says that NoSQL is not NoSQL but non-SQL. Anything which is not relational falls under NoSQL category. The main differentiator is the way data is structured. So people say the most common the most common line, yet a misconception which is widely accepted, is NoSQL is schemaless. No matter how much we say that NoSQL databases are schemaless, there is still a underlying schema that each document adheres to. Right? Just imagine if you are using MongoDB, DynamoDB, Elasticsearch. Although it supports you to add as many fields as you can or keep entirely schemaless, but you would still see homogeneity across the documents which are inserted. Because if it would not be there, you would not be able to query things. Right? So it says schemaless with respect to giving you a flexibility to have a certain attributes be present in some documents and be absent in others. Right? So that is really important to understand. So schemaless is a feature of NoSQL, but not the primary feature. The primary feature of NoSQL is the thing why you should be using NoSQL is it does not have relationships. It does not have foreign key constraints and all of those parts, right? Because of which it is very highly scalable and available because it gives you sharding by default. Like if you run a Cassandra database even locally, it starts with asking, okay, how many shards do you want? Well, that's the first thing that it asks, right? So even the most basic thing when you start about a NoSQL database, its ability to provide you sharding on day zero, which is something that SQL doesn't give you, right? Every database had some strengths and some weaknesses. So always keep in mind why are we picking one over other. NoSQL databases typically compromises on consistency. So the data that you give, it might be eventually consistent. Means if the data is, if you say that data is stored in a certain place, it gets time for your data to become eventually consistent. Let's say you have inserted 2 rows, both of them dependent on each other. They might not happen in the same transaction because there is no concept of transaction. Basically, there is no concept of atomic transactions across multiple statements here. In most databases, there are obviously lines are getting very blurry right now, and each database is trying to copy the best feature of other databases, like MongoDB gives acidity and whatnot, right? But still, in most cases, you'd see that NoSQL databases give you eventual consistency, which means even after the transition is finished, it might take some time for data to become consistent, which is okay. If your system can live with eventual consistency, NoSQL would become a great choice, right? So this is a classical case of cap theorem. This is something that is already a lot of resources available on the internet. I really would not want to spend time talking about what cap theorem is. Basically, consistency, availability, and partitioning. You can have two and not all three at the same time. So what do you do when you are making NoSQL? You are signing up for you are most probably signing up for eventual consistent system. But since it is giving you eventual consistency, it will give you very high availability because your data is by default sharded. It resides in multiple places. Even if one of the machine goes down, other machine can take place of it. Your data could be replicated across shards. For example, if you're using Elasticsearch, with Elasticsearch, when you have multiple nodes, you can you can configure a replica set. You can configure what's the replica factor of my data, and depending on the configuration, it would replicate that one document of your Elasticsearch across multiple shards present on different machines. So even if one of the machines go down, the query is automatically redirected to other machine and it serves from that. So it gives you very high availability, but your data is eventually consistent, right? So always think about like the core features that you want in your system and then pick the database. right? That's the ideal flow. But with as far as my experience goes, I've always seen that there is expertise of a certain database in the organization, and people would want to use that, right? And adoption of newer technology, unless it is revolutionary with respect to performance and malab, either performance or cost or whatnot, malab, something which is like a massive delta, then only it gets adopted, right? But you should always, as an engineer, you should always know like what's the best database to use for this, and and basically what are the features that you definitely need while implementing your system, and then you pick the database. So read about Cosmos DB, DynamoDB, Google Spanner. Research papers of all the three are available on the internet. Go read about them. Their architectures are very simple. You'll understand a lot of things. We will be trying to cover some parts of it in terms of a future design thing that will be picking up. But still, it's better if you can just skim through it. Yeah. Now, with respect to types of NoSQL databases, the most famous one is document DB, which is like your data is typically stored in terms of documents like MongoDB, Elasticsearch. These fall under document-based databases. Then comes key value store, something that we already know, like our DynamoDB, Redis. These are key value stores. Then there is wide column databases. Typically, it stores the data in tables, rows, something similar to SQL, but each row does not really need to adhere to same set of columns. So it's like two-dimensional key value store. So like a great example of wide column data store is Redshift, like Amazon Redshift. Any columnar data warehousing database would be an example of wide column store. So it may, for every row you can have different schema. So it gives you it arranges your data in terms of rows and columns, but it is schemaless. That's wide column data stores. And then graph, we have all heard about graph databases, nodes, edges, relationships. These databases are typically optimal for graph use cases, but more specifically when you definitely need graph-based algorithms to power your system. Right. Otherwise, you can very easily model it with SQL. Yeah. Now we'll start diving deep into each one of them, and I'll share a couple of things around it. Okay. Document databases. These are mostly JSON based. Mostly JSON based. There are other formats as well. Avro, Parquet. There are databases that supports Avro format, Parquet format, and all. But typically, since JSONs are the most human readable format that everyone is basically, JSON is the universal language of communication across system. So people typically prefer that. So most document-based databases are JSON-based databases. There are other formats as well. You can obviously understand what the format is, how it is good. Names are Avro and Parquet. Google about it if you are curious. So the main advantage of document-based database is it gives you flexibility of NoSQL, where it is schemaless and all, but it gives you ability to query within the document, which means that the value is not treated as a blob. The value is treated as something which you can query within the value, like attributes and all. In terms of JSON, you can query within that. Right. So that's the difference between a normal key value store and a document-based database. So document-based database, you are allowed to query within each of the document. Every document gets a unique key. Either you provide it or it is auto-assigned by the database engine. You can create secondary index on any nested fields. You can have partial updates to documents. This is most amazing with key value that we designed yesterday. And in most key value store, you would find that partial updates are not possible. Only full body or full value replacement is allowed. But with document database, you are allowed to make partial updates. Right. So while picking any system, understand the kind of use case you have and then make a choice around it.
What's a full value replacement? Can you?
So when you do basically when you put key comma value, if you let's say your value is a JSON document, big JSON document, right? So full value replacement implies that whatever value you give it, it would override the existing value. You cannot just change one value. like for example, you can't give, let's say I have JSON document having name, age, and address. While I'm giving an update, when I'm doing a put, it would do against this key, give me the entire new document that needs to be replaced, or rather that will take the place of my original value. I can't just say ki yahan pe just change age to be equal to 10. I can just say that just modify this when I talk about full value replacement. Right. With respect to MongoDB or Elasticsearch, you can just update one attribute of the document and it would keep other fields as is. Right. But when in a typical key value store, the value is not partially updated, but completely replaced. So you would always have to provide the complete document, even though you are just changing one attribute within it. But again, lines are getting very blurry. If you see JSON is a, if you say Redis is a key value store, but usme you can have a partial, basically partial value replacement. You can have separate operations. So lines are getting very blurry. So understand what kind of functions are you using. Like set function of Redis is a full value replacement. But if your data structure is list, set, sorted set or something, you can make partial updates, like just add a new element to the array or something. You can make things like that, right? So JSON document or basically document based database, you're allowed to make partial updates, but key value store mostly it's like full replacements. And key value store value is not treated with granularity. It's mostly, basically you cannot write complex queries on top of key value store. So complex queries as in querying within the value, right? So some operations, and again, lines are getting blurry between databases. So understand the kind of systems you are using. This might have been true about 4 or 5 years back, but every language is trying to be every other language. Every database is trying to be every other database, right? But this needs to be kept in mind while invoking the correct function for the database. Right. Now, next database is columnar database. This is really important. Matlab, this columnar DBs are really important. Why I would say this? Because whenever you have a use case, like what it's the, so basically columnar DB looks very similar to our relational databases having rows and columns. Even the structure is same, but columnar DBs store data in columns and not rows, which implies that in the first week and yesterday when we were discussing about relational database storages, we found that one row was sitting together on disk. Right? With columnar database, one column sits together on the disk. Like, I'll give you a very small example here. So with a traditional SQL storage, this is how my rows are stored onto the disk, right? So this, each one will have, let's say 5 columns. So this is row based storage. So each row is sitting, so all the cells of a particular row are sitting together. This is typical my row based storage. Now, when I talk about my column based storage, what would happen is, let's say this column A, B, C, D, and E. With columnar storages, what would happen is my column A of 3 row would be sitting together. Column B of my 3 row would be sitting together. So row based storage mein what would happen is the rows data is basically closely associated. With columnar storages, my column data is closely packed. What's the advantage of this? So what happens is, with columnar database were primarily introduced to make analytics queries very efficient. So analytics query as in, what would you do? Let's say your table has 100 columns, right? Let's say we talk about stocks and all, right? So what would happen is, if I want to run analytics query, what I have to do, I have to go through a lot of rows to compute some aggregation. Let's say some min, max, percentile, and whatnot, right? Some sort of aggregation I want to perform. So then I have to go through a lot of rows. But if you see the use cases with analytics query, you would be utilizing only a fewer set of columns and not all. Let's say you want to do summation of revenue generated by my company in last 1 month. And if I have data for each hour, how much I did, and let's say that table has 50 different columns, then I'll be iterating through all those rows and just utilizing just one column of it. This is very bad. So basically row-based storages are very bad for analytics use case, because now what would happen is when you want to do this, you would have to literally go through the rows. Like you would be just like, say B is the column where my revenue is added, C is the column of my timestamp, right? So I would not, I'll still, when I'm iterating through it, I'll iterate through row by row. And when I'm iterating through row by row, I'm just reading this data in memory, but not really doing anything about it. So my disk seek time, or my time to fetch the data from the disk, increases, right? So time to scan is proportional to the amount of data read from the disk, not utilized, but read. So with this thing, let's take an example of stock. So what would happen is I have a symbol, I have a price, name, exchange, and date. Now what I would say is I want to find average price. I want to find average price of one of the stock on a certain day. If this is the use case that I have, when I'm running this aggregation query, if it was a traditional SQL storage, row-based storage, what would have happened is I would have to go through all the rows for this day, and I would not be utilizing name or exchange columns of it. I would just need symbol, price, and on this day, right? So I don't really need to access or to even go through name and exchange. Scale this problem to having hundreds of columns, and you are performing analytics or you are performing aggregation on just a couple of them. With this thing, what has happened is to perform that aggregation, I would have to go through all of them. Well, for that particular date, I have to go through all the columns irrespective, because the storage is row wise. Now just switch the rows, and instead of storing it row wise, store the data column wise. Now what would happen is if I have this kind of use case, let's say A similar to B, then similar to C, and D, and I have E. Now what would happen is, let's say I'm performing aggregation query, and this is how my data is stored on the disk in terms of my columnar storage. Now say if I want to do it on B's, A's symbol, price, name, exchange, and date. So symbol, I would read this column, then price as in this column, I'd skip this two and this column. So A, B, and E. So I'm not even reading the files, or I'm not even reading the files which stores data of column B and column E. So with columnar storage, each column, think about it, each column is stored as a separate file. So with this, what happens is only the columns that are part of my query will be the ones that will be read, will be scanned and read, which means I'm not wasting any of my disk IOs reading, basically going through the data of other columns which are not even part of my query, which was the case when we had data stored in row-based format. So this is why your analytics queries work really well when you have column-based storages, because most of the analytics query, what happens is you would have 50, hundreds, 200s of columns, and you would just be querying upon 1, 2 of them to just find the aggregated number or something. Right. So this is where columnar representation reduces the scan time. And since it reduces the scan time by reducing the disk IO required, by not unnecessarily reading the data and just then basically discarding it, it does not waste any disk IO. So that's why queries run really fast. Right. Now, a typical size of a data warehouse based table is typically at least 50 to 100. That's the average that it goes, because that's where it's the power. And if you see, this is also schemaless. You can have a certain column on a certain row, but you can skip it on other end. Right. For example, here for something you might not have date, for something you might not have name, for some row you might not even have exchange. That's okay. You can have, you can choose to have a certain column on a certain this thing on a certain row and skip for other rows. So it's schema-less with respect to the columns that you have, right? And this makes query really fast. Now, what's icing on the and basically what's icing on this cake is you can compress very well, because now what would happen is your data, wait here only, because your data is very homogeneous. Now, if you see, all the data of a certain column is sitting together. Like all the data of column A is sitting together here, B ka sitting together here, C ka sitting together here. Now what would happen is, since the data is homogeneous, let's say all are integers because it's storing price. Yeah, all are dates. Let's say storing date type, or it's symbol. So all are short strings like AAPL, MSFT, something like that, right? So you can have a very specific compression technique through which you can compress homogeneous data very well. So the typical compression ratio for columnar database is more than 95-96%, which means even lesser IO needs to be performed. Like we are already not doing IO of columns that are not required by the query. We are already saving that. But on top of that, if we compress the data, it would be even less of an IO that would have to be performed when we are trying to read data out of this. Right, so that's a great advantage of using a columnar storages for analytics based use cases. So that's exactly why Redshift uses Postgres, but it has transformed it into a columnar storage. So Redshift, of an offering of AWS, is built on top of Postgres database. It stores data in terms of columnar, with the strategy of it being storing data in a columnar database, right? So data for certain column resides together, another column resides together, and then depending on the query that you fire, it would go to it, read only that much, compute the results, and send you back. It's really efficient way to do it. They've just flipped the things, right? Chal, let me take a few. Just one thing before I take question is what you should be reading about this is columnar compressions using a great example you might have studied in college and all. It's run length encodings, like how you can do run length encoding on homogeneous data. Read about them. Read about columnar compressions. Read about ways through, well, how homogeneous data can be compressed more efficiently than row-based data. So why columnar database have really high compression rates. And there is a database called C-Store, which was the first columnar storage that was introduced. They have a great research paper about it. Go ahead and read it. That's a great one to read. You'll see how people have thought about this use case in depth and how they've solved it. Right. Let me take a few questions. Yeah, Anshul.
Yeah, so Arpit, in columnar database,
Hmm.
how one column's value is linked to another column's value? Like,
Great question. How would you do it? Let me ask you.
uh, I don't know. One of the thing can be there is a pointer to another column, or like main problem is one of the column might be absent. If all the
Hmm.
columns are necessary, then it would have been easy. Like zero
Correct.
will be mapped to zero.
Hmm.
But the problem I am
Hmm.
facing here is
Hmm. Hmm. So your first solution is what? Using pointers.
yeah, but
But
that won't be efficient. Like it will take extra
whom to
memory.
whom? Basically pointer to what to what?
Uh, Not sure.
Think,
Like
think, no, think. See, you are
uh,
the database designer. Think, how would you do it?
it might be like from A to B if B is present.
Hmm.
Otherwise, it can be linked to another column which is
Hmm.
present after that. A to C, then C to D, something like that.
So for each row, you are trying to basically weave a thread around it.
Right.
Correct. So for each row, see this, then this, then this, then this. Okay. Anything else that
But
I can do?
So
but it
Arpit,
will be having a problem. Like if I want to access A and F,
Hmm.
then otherwise it will be
It's
like a link, but
hmm.
it won't be efficient.
Hmm. You only gave the answer. What's better than that?
if we are storing homogeneous data, let's say integer, and we
Hmm.
already know the byte length, and if we know the starting index of first row, then we can
Hmm.
just put number of times into row into a byte.
Correct.
Yeah, it's 4 bytes. Then we can
Correct.
jump on to the second text B column and similarly C and D column.
Correct. You guys are only giving me the answers. I'm not even saying it's typically based on offsets. So every row, right? Like for example, you have row ID, right? So row ID is nothing but like this is my row number. Let's say 0, 1, 2, 3, 4. You know that I've iterated to this. Now, since I have homogeneous data, what I would have is I would have fixed size packets because it's typically SQL like storage. Like you would have some fixed width for that column, and it's typically offset based because pointers are not in a, because basically pointers here are not efficient because you would, if you are weaving it from one column to another column to another column, what would happen is you would still going through that, right? So you obviously the better solution to that is using offsets. So every row having that column is stored as an offset. So storage is a little tricky because the column might be present or absent, it might be dynamic. So offsets are stored a little differently, but offset information is stored along with the data. This is at this offset, and then you do a binary search to basically locate that offset. So you can find it on the white paper of Redshift. They have defined how they have done it. Or you can anyway go through CSTOR's research paper. It has that information as well. Great job. Rana?
So I think what happens when you have a write heavy transaction system in this columnar storage, like
Columnar storage is not meant for write heavy.
Okay.
It's there for analytics use case. See, that's what I was talking about, right? Analytics query.
Okay.
It's not meant for transactional data. It is meant for a read heavy system. So it's typically write once, read many a times, basically kind of a system. So the data is there, the data is stored, and then you have to perform a lot of analytics.
Thank you.
Yeah, Rahul?
So is columnar DB a schemaless or does it have a constant schema?
Schemaless. It is schemaless. So a columnar database may every row can have a different schema. So
Then
that's
how-
why typically you can have hundreds and 200s of columns in it. Some rows might have some columns, some rows might skip other columns.
So if you try to iterate, then it will take a longer time, right? So
Basically, that's not what you'll use this database for. You'll always use this database for analytics query. So if you're using it for analytics, this would do wonders. If you are using it as a normal SQL database, this will give you a pathetic performance. Matlab, I recently did a consultation for a firm in Dubai, and for some reason, someone suggested them that, okay, you have analytics use case, use Redshift. And they had a real-time analytics use case, not doing analytics for the sake of analytics, but they had to do real-time analytics for all of their customers. And some other consultant actually suggested them to use Redshift, and they got response time of 15 minutes. Obviously, that would happen because Redshift is not meant to serve a traffic like that. Redshift is not meant to serve real-time analytics. It is so any columnar database would not serve real-time analytics. It would do a great analytics job, and analytics job are meant to be something that can take a long time to be completed. So understand the kind of database, the kind of use case it is meant to solve, and use it for that thing. If you have a certain use case and you are trying to mend your way to use that certain database because that database is optimal for that, no, that won't work, because this kind of use case are not meant for real time. Real-time analytics is typically driven by other kind of systems and not a columnar database. So there are columnar database meant for real-time analytics, but this is definitely not one of them. Chalo. Yeah, Vishal?
Yeah, so I wanted to know which sites do you use for white papers and research papers generally?
Which site?
Or general Google search.
Google Scholar. I just love Google Scholar. You'll
Okay.
find everything there.
Okay, so on that Dubai's consulting thing, so which option did you go for? Druid.
We use Postgres, normal Postgres, not any columnar storage.
Okay.
Apache Pino, I could have suggested Apache Pino, but that's too heavy for them. Their use case was fairly simple. They should have used SQL. It's just that about if you are trying to solve real-time analytics, and this is a little off-topic discussion, but a really interesting problem to tackle. So in most cases of analytics, right? So columnar storages are very efficient to do analytics, right? But they are not meant for but they are not meant to do real-time analytics. SQL databases, on the other hand, they do a great job at aggregation, but they are a little slow, right? But why are they slow to do aggregations? Because they have to skim through a lot of data, right? Now, what happens is, if your data is indexed well, you can avoid going through unnecessary columns, correct?
Yeah.
So create your indexes such that you do not have to go through, like for example, if this particular schema that you are seeing on the screen right now, like your symbol, price, name, exchange, and date, if you create an index on symbol, price, and date, right, and you tell your SQL query engine to use this index to query it, you are typically avoiding what? Name and exchange, which is something that would be out of the box for a columnar system, correct? That would solve problem number one. Another thing, with that index, what would happen is, with time, that index would become very big, right? And with most cases for analytics, you are doing like last 1 month or last 1 week or last 1 day worth of analytics. You are not doing massive, because when you're talking about real-time analytics, you would always give them the last 1 day mein how many transactions happened, or last 1 month mein maximum how many transactions happened. So depending on the maximum time that your product is supporting, archive older data. Through that, you'll keep your index size very small and your query is lightning fast.
Okay.
Right. So it's all about utilizing your resources well, keeping your indexes smaller, and just getting performance out of it. It's mostly about, like, if you don't need that data, why to even keep it on your database, right? Because that's when your index size would be smaller. Right. So if you are building something like real-time analytics, think about it, because SQLs are meant to serve those kind of use cases. They serve a great real-time traffic. Right? So you can just hack your way through it.
But in that case, you'll have to constantly fire SQL queries, right? And to update the data.
Yeah. So data was anyway updated here as well, because the transactions are happening now. So where would the transactions be registered?
Yeah.
If the SQL is a source of truth, let's say you want to see how much of revenue did I get in a certain day. It has to be there in a payment database. In a payment database is SQL database. You are anyway making an entry there. This is an additional thing where every transaction which has been registered here also is stored into this columnar database.
Okay. No, columnar is fine, but in the SQL Postgres wala thing, you'll have to constantly fire, keep on updating every X seconds, right? To get a real-time feel of the.
No, every time it happens, it would do a fresh computation.
Okay.
So
Okay.
I don't have to run a cron job to check it. Whenever the request comes in, I'll serve the real-time analytics. And obviously there will be a caching period of 5 minutes or something, basically whichever is acceptable by the product. Most companies do this. Like,
Okay.
I was going through Algolia's Tech Talk or something. They did this very thing. They use SQL to store bunch of analytics data, and they give analytics for last 1 month, and then they cache it for 5 minutes, and they say that our data will refresh in 5 minutes. It's mostly about basically trying to reduce the number of requests coming to your for your main transactional database for analytics. So they just say that we'll cache the results for 5 minutes or something. So they have this tick time on after how much time you'll see an update. So it's one more use case like this. I think Amazon CloudWatch also does this. Not really sure about it.
Abhijit, like to add one more thing to this, like, what you can do is when you're defining real-time analytics, you know that on which configuration you're defining those analytics. So whenever there's an update on such configurations in the database, you can just like expire your cache on that. So that's something I actually built it like, few months back in my current like company. So that's also one way, like rather than like when you get the request for the first time, you make a call to the SQL, get the data and store it in a cache, and you know the configurations on which your analytics has been defined. So as soon as like whenever there's an insert or something in those configurations, you will have a trigger as such that will like flush the cache.
Yeah.
Yeah.
Sure. Nice. Great detour. I love this kind of detour. Sure. Now, next kind of database, graph database. So, I'll just take questions a little at the end. Vishal and Bhupendra. अगर कुछ आता है तो just bug. Thanks. Graph database. Graph database stores data in forms of nodes and edges. A typical graph database like our adjacency list, representation, and whatnot. Something that we have studied in the data structure school. And almost that's exactly how graph database also stores the data. There is no such like magic representation to do it. But it's very important to understand where should you use graph database. Most people fail to understand it. They see, "Arey, this use case is graph use case. Let me use graph database." The only query that they would be firing would be about just finding if the relationship exists or not. Like use graph database. Graph databases are like Hulk. Like you can't just, if you want to use graph algorithms which are not optimal to do on a SQL storage or a NoSQL kind of thing, then you use graph database. If you're using graph database just to find out if the relationship exists between two entities or not, that's just like a very key value kind of use case. A very small example should be, how will you model following relationships? Like A follows B and B follows A. Right. So this is just like, if I just want to answer this question, like, is A following B? Right. If I just want to answer this, and if I store this relationship into a graph database and not really use any graph algorithm, I can very well model this into a very simple key value store and have it sharded. Like a very simple example would be DynamoDB managed service, automatically sharded. I can just create a composite key using a following and follower key for both the user ID and just make it a composite key and store that entry. And all I have to do is just check if the entry exists or not. Right? That's a very simple use case. Why should I be using something as big as a graph database if I'm not leveraging any graph algorithms on top of it, right? Because single key value lookup would be lightning fast as compared to graph lookups. But if this is where the interesting part is, if your use case is to find, if your use case is to have graph algorithms, a great example of this is LinkedIn connections. LinkedIn was the first website or the first product that showed you the degree of separation between two people. Now, for everyone, you see one or two only. Earlier, it used to be 4, 5 also, right? Because this, how far is the other person from you in this social network? That is a great example where you would want to find out, or you would want to run the graph algorithm to see how far are these two nodes in this cluster of nodes that I have. Right? That is a requirement where you should be using a graph algorithm. If you are just building a Twitter and you have A following B, you should not be using graph algorithm or a graph or a fully fledged graph database like Neo4j, dgraph, or Amazon Neptune to store that information. You can do it, but you should not do it, because that's like using Hulk to open a jar ka glass, jar ka lid. No, it's like that. So understand the kind of use cases that you have and then choose a graph database. Another great use case for graph databases is recommendation engines. Because when you're doing something called as collaborative filtering, this is something that you're hearing for the first time. Read about it. We will cover it anyway week 6, 7 May, but it's okay to पहले से थोड़ा पढ़ लिया. So if you're building recommendation engine where you say that if A has purchased an item I and B has purchased an item I, so A and B are very similar people. Right? This is a graph problem where you have, like, if you are Amazon, you have all the products. Two people buying same set of products are close to each other, so you can recommend same things to them. Right? This kind of use case is very well modeled in graph ecosystem. Right? So this is where you should be using graph. Right? Not for storing following relation. You can do it, but you should not be doing it. Like you can very well model it using key value. Right. So this is very important to understand. Why? Because this is, this is something that can, because graph databases are very expensive to host on machines. Even if it's a managed service, it will cost you a lot of money. So graph database is better. It's always better if you can model it on SQL or model it on a sharded NoSQL like DynamoDB or key value store. That would give you much better performance there. Right. Something from my real experience. Right. But do try this at home. Try to model a graph database on top of SQL. It's really fun to do it. the way you are thinking of doing it in terms of data structures, algorithms, scores, that's exactly how you are going to model this on SQL storage. Think about how you can do it. There are 3 ways to model it on SQL storage. One of them is the simplest one, but not a lot of people can think about it. If you can think about that, great. But do try to model this on your SQL storage. I did this and I learned quite a bit out of it. So this was one of the first things that I did after moving to Amazon, because at that time I had this craze of diving into graph databases and see how they function. So I started going through Neo4j's code base, and it was written in Java, and I said, "Arey, yeah, shit." And that's when I discovered dgraph. So if you want to know, or if you want to understand how graph database works, dgraph is right now the most popular one. It is built by Manish Jain, a great person, a great dude. I had a privilege talking to him once. Uh, he built this open source thing. Now it's a full-fledged company, dgraph. Their code is so simple. It's written in Golang. Their code is so simple to understand that like just one skim is more than enough for you to understand what kind of architecture are they having. Like that's a great way to understand. Like if you were to build a graph, not on top of SQL, they have used embedded databases for that. But if you want to build graph databases, how you can think about it. Right? That's a great way to start going into graph database if you are interested. So try to model graph database on top of SQL engine. Very easy to do it, but you'll get a very interesting understanding. And then if you pick the right approach, you can see how you can tweak a few things and model it into NoSQL and make it infinitely scalable. So that's a great exercise to to get a deeper understanding of databases. Okay. Any questions till now? I see 3 chats. Yeah, exactly. That's the video I was talking about, DB based. Bhupendra did share it on the chat. Yeah. So any questions, or should I move forward with NoSQL scales? Next. So let's move to why NoSQL scales. Yesterday we talked about why SQL scales and why they do not scale. Today we'll talk about why NoSQL scales. So NoSQL, the reason NoSQL scales is because of partitioning and sharding. Anything is infinitely scalable only when it is horizontally scalable. If it is not horizontally scalable, then there will be a limit after which it will stop scaling. Because vertical scaling has a limit because it is bounded by the machine on which it is run. So a truly scalable system is something which is horizontally scalable. So it has to utilize partitioning and sharding. Interchangeably used terms, but we will treat it as synonyms. So if your database is sharded, then or if your system is sharded, then you can very easily scale it to like must value scale. Okay. So why? So NoSQL, what they leverage is they have data denormalized, which means that they are not restricting you from having redundancy in your system. Like if your data, like in MongoDB, you have one document. Let's say you have a user card collection. In that user collection, you want to store 5 addresses of the user. In SQL world, you would have a separate table for user addresses where you'll store n addresses out of there. You'll have a separate table that maps user ID to address ID. And in users table, you would just have all the users ID, right? And then to get all the addresses, you would do join between users, user ID, address ID, and addresses table, right? Now this, although it reduces it reduces the redundancy or duplication of your information, because now changing address at one place would actually do the job. With this, with NoSQL world, it says that have redundancy in my plate. I'm schemaless, add anything you would want, have data duplicated. I don't care about it, but what I'll give you is I'll give you a very good scale, right? So you cannot enforce constraints on NoSQL databases, but you can mimic them on application level. You would say that, okay, this happens, then only I'll say write has happened, right? You can model SQL into NoSQL, NoSQL into SQL, but you need to understand why, one would serve a certain use case better than the other. So here, with data being denormalized and mostly schemaless, what will happen is you can split the data into multiple nodes. So with SQL, everything has to be contained in one node. Through that, what happens is you're limited by that machine. Here, data is split across multiple things. If you want to scale, add one more node. Do a bit of data migration, add one more node. Right? That's what the benefit of sharding is. Right? So you typically partition the data on a certain partition key. Let's say if you're building Twitter and what you want to do it is we're building Twitter and you want to have store tweets in a sharded manner, you would store tweets partitioned by the author ID. Let's say who the person who tweeted it. Through that, what would happen is all the tweets of a person would lie in that one database. Now, if you're querying something about that tweet, or if you want to fetch all the tweets of a person, it's very easy because it doesn't have to go to a lot of database to get it. It can just go to one database, fetch all the tweets of a person, and very easy to do it. So when you are picking up NoSQL, your design decisions are very important. Like on what parameter do you want to partition it? On what parameter or what kind of strategy would you use to scale up, scale down, and things. Like if you're modeling it on DynamoDB, you'd have to think about what's your partition key and what's your range key. Like on what parameter do you want to partition the data, and within that partition, on what parameter do you want to keep the data sorted? Something that we studied during clustered index. Right? This is very similar. If you see, a clustered index is nothing but a partitioned data kept together. Right? You would have sorting criteria on one, then another, and then another, depending on your clustered index. And that one, for that one unique or that one cardinal value, you would have that one entire row, well, all the rows that maps to that particular value. This is very similar to that. So you would have to think about your schema much in depth when you are picking a NoSQL system. It's schemaless, but it's challenging to model it. Okay. So your engine just needs to visit the node that it holds the data and send it back, which is something that I discussed, that if your partition key, so all the queries that you make onto the system will need to have that partition key. So your use cases should always be like for a certain key or for a certain user, you have to do it. And then you would be using that as your partition key, right? So that it just goes to one node and fetches it. If you're not doing that, your query would have to go to all the nodes and then someone has to aggregate and send it back. So that's a very challenging thing. So that's why most of the databases enforces you to have a partition key and allows and demands you to provide partition key on every request that you fire. Right. So one way that your database would keep a map, like something that we discussed yesterday while designing key value store, is like there has to be someone who keeps a track key. Where is the range A to Z maps to? Like yesterday, it was the first level intelligent load balancer that had this. Here, since it's a native database, in that database, there has to be that one interface that just sits at first and sees key, I'm getting data for this partition key. Now I'll see that like basically this is where I'm talking about my range-based partitioning schemes. So for A to M, go to DB1, for M to Z, go to DB2. This is something that is configured on my main database. So then this is the one that makes an intelligent decision. Key, where do I have to forward my request to? Right. This is something that could be done by client or by database gateway. There are multiple ways to implement it, but there has to be someone, some authority that has this information. Right. This kind of thing would come in very handy when we'll be designing S3 in the future, because we'll see the true power of this, of having this thing abstracted, and what kind of advantages would it give us. Right. So this is a typical example of range-based partitioning. You can have a hash-based partitioning where you're using key and doing a hash and then storing it at a certain place. Range-based partitioning has its advantage. Then you have fixed partitioning, like everything related to Apple goes to this database, everything related to Microsoft goes to this database. This comes in very handy when any example where this kind of partitioning scheme, where fixed partitioning scheme would come in very handy.
I mean, I'll say location because I mean, maybe if the user is from a specific location, better save them the same sort of thing.
So you are what you are doing is, instead of specifying range, You're specifying that A should go to this database, B should go to this database, M should go to this database. You know,
If the values are very limited, I think that makes sense.
any other example?
Stocks.
Great, stocks. But why? Why stocks? Because values are limited. That's okay. But any other thing?
Traffic might be higher for a particular stroke and lower for some other.
Exactly. Everyone was trading Dogecoin a month back, right? How would you scale? Let's say you are WazirX, or what's that other platform, WazirX or the CoinD6 or some platform like this, and the entire world is trading Dogecoin. You are seeing a lot of traffic for that one or two entities, right? You don't want that entire system to crumble by just having one being traded a lot. So what you will do is, that this is going to be traded, or this is my hot entity right now. Let me give it a separate existence, right? Think about this in terms of social media. Twitter verified profiles, Instagram verified profiles, more than 1 million followers. Whenever this person tweets messages or something, you would want to have a different strategy. You don't want these people doing something which would take your other system components down. You would want to have a separate database to handle this kind of users. Right? So think about this, when you have this, where you want to give special attention to a certain entity. Extending this to a B2B model, where let's say you're running a B2B company where your customer says that I want complete isolation for my data. I don't want to share the database with any of your other customers. That is also a place where your fixed partitioning would help really well. Because then what would happen is, instead of having A to M, you would say that let's say Apple is my customer, all the data of Apple is stored in DB1. Or let's say my other customer is McDonald's. All the data of McDonald's will be stored in DB2. Similar to that, as and when I'll onboard a new customer, I can just add one mapping to this. I'll provision a new database and then add a mapping to this. Right. So complete isolation. So whenever you are building a tenant-based application, or whenever you need isolation, or whenever you need to give special attention to a certain entity, or when you have a limited set of entities at hand, fixed partitioning works really, really well. Yeah, Rana?
So while reading something, like let's say we are reading a NoSQL database, any of let's say graph database, beforehand we'll need to know what exactly we are reading. So
Yes.
saying it like schemaless might not be a perfect term, perfect, and like schema on read is possible in SQL. Is it fine to say?
don't go into vocabulary and stuff, but typically it's all schemaless because it does not ask you to, well, it does not enforce you to have those set of.
Right. So while writing, it doesn't enforce, but while reading, one has to
You
know.
can just keep on read. Now that's a little vague to
Right.
say. Well, people would still generally call it schemaless only, but basically schemaless on write, but schema full on read. That's a little weird. But obviously everyone understands that. Yeah, like you'd need to know if this kind of thing is something that you would have to know the attributes that you would want to query upon.
Right.
So would you really want to give it a name? मतलब ऐसा होता है ना कि बेसिकली कुछ रिलेशनशिप्स है जिसका नाम नहीं देते, ये वैसी है. चलो. Yeah, Anshul?
Yeah, so in MongoDB, do we have sharding by default? Like if we don't define the sharding, that like in this case?
MongoDB starts as a standalone instance, but there are command line options through which you can configure it as sharded.
Okay, until we shard specifically, it will be in
one.
single node. Okay.
Elasticsearch where you have to shard, you can Elasticsearch has logical shards similar to Postgres. So Postgres internally has logical schemas. Elasticsearch has logical shards and physical shards. So you can have n number of logical shards split across 5 nodes, and you can say ki this shard resides in this node, this shards will reside in this node, and then you can shift from here to there. So
Okay.
there is this abstraction that is given to you by Elasticsearch. MongoDB mein there is no such thing, but there are options through which you can configure sharding on that.
Okay. So in case we hit a certain scale and we have to shard the data, in that case we have to migrate the data from one node to another.
Typically, it is taken care by database engine.
Okay.
You
So
don't
there
have,
won't
you
be
would not have
any
to do it.
downtime in that case.
A downtime thoda sa aata hai. When it makes that flip, then the downtime comes up.
Okay. Got it. Thanks.
Sure. Yeah, Varun?
Yes, I just want to know, like, if we have a requirement of white label solution, okay, and as you
What's
are
white
saying
label?
that
What's white label?
a white label solution where means I am providing a service where my end users can also provide a service.
Acha. Okay,
Yeah.
ठीक है. हाँ.
So in that sense, do you think that we have to use different databases, or what will be the right approach?
No. It depends. It depends on how your basically it depends on what your customer wants. If your customer
Okay.
needs complete isolation, then you give it. Otherwise, no.
Okay. Like you said that, okay, there is a Apple is my customer, so
अगर
I
बोल
will
रहा
have.
है वो देना है तो दो.
Hmm.
Don't like.
Okay, then it will be very costly, right? Not a
और नहीं
good
बेटा. For
decision.
everything if you do one database spin-up, then तो
Hmm.
मतलब पैसा ही फूक जाता है. हाँ.
Okay.
अच्छा. Basically, this is the slide which I was finding. Where did I wrote this? हाँ. Read and understand the foundational paper on DynamoDB. That's a must read. But if you have not read it, go and read DynamoDB's paper. Great one. They used or they basically made consistent hashing really popular. Go read that paper. Go read the paper on CStore. And that the title is CStore, a column oriented DBMS. That's exactly the name of it. So you can read that part as well. Okay. Now what? We talked about NoSQL. Now NoSQL has what? NoSQL has no joins. But if you want joins, now what do you do? Right? So when you don't have joins, you always fall back on your application side. So what you do is one join would be multiple selects. Make sense? Yes, no?
Yes, Arpit. Like there are three entities, and we can select each of them, and upon basis of that we can join.
Merge it, right? So remember this.
Arpit, can you please repeat that again? Really sorry.
Yeah. So since NoSQL does not have joins, but if you need joins, how will you have it? Like for example, it does not have foreign key constraint, right? So it you cannot like from user. Let's say you are modeling users and address in NoSQL. So let's say you have one collection for users, one collection for addresses. Right? How will you do it? How will you model it? Let's just try to model it. Maza aayega. Let's try to model users and addresses. So let's say we are using MongoDB, and you have one collection for users, you have another collection for addresses. Okay, one user can have multiple addresses, right? So how will your schema of user look like, and how will your schema for addresses look like? State, country, city, and area, something, right? And it will have its own ID. Right? For users, it will have name, some bio or something, and then it will have addresses. Now, what will you store here in addresses?
ID.
You'll store IDs of something, right? So let's say A1, A2. Let's say ID is A1 here. Now, when you're making this query, so this is a typical NoSQL schema. You have users, you have addresses. Now, when you want to have or when you want to surface users profile, you also want addresses as data. So what will you do? You'll make one query to get your user, your intended user, right? Then from this user, you'll get addresses. Addresses where you'll get multiple IDs. You'll use those IDs and make query onto addresses column where ID in this. So one query goes on users, another query goes on addresses. So and then you are joining the data, right? You're typically joining the data where on the application side. So this is how if you don't have joins on SQL, your one join is nothing but multiple selects.
Got
Right.
it. Yeah.
But Arpit, in this, like
Hmm.
we will have n square queries, right? For each ID, like for each user, we will have to do.
If you're fetching multiple user at once, then obviously yes. But if you're just fetching one user at a time, that's when you are just making two queries. But what you're talking about is something that we'll discuss in 5 minutes. Just wait for 5 minutes. I know where you'll go. But pata tha aapko uska. Okay. So what would happen is this works well. So typically having one join multiple selects is something that works really well in some database, but it depends on your use case. So always benchmark when deciding, do you want to normalize the data for your NoSQL use case, or do you want to keep data denormalized? Coming to the point of denormalize, another way to store this information was to store the actual, so not have addresses collections at all, and store addresses within users collection directly. Right. So typically, if I want to store this, instead of having this as separate this thing, I can just store it within this like this. So I got rid of addresses completely, and I stored addresses data here within the column. So I've denormalized data. Right. This is a classical example of denormalizing thing where I'm just clubbing a lot of data into one document. The disadvantage of this is the document size would become really big. But if you have a use case where you want to always surface the entire document, and basically that's how document database work. And if size is not getting too big, do follow this. Having to make a separate query is very costly because it would be a network call. Network calls are much costlier than just making one call to the database and fetching a lot of data at once. So with denormalization, instead of storing foreign key, store the value directly and thus avoiding another lookup. So with this denormalized data, you're just making one query to users and fetching your user profile, right? and not needing to make another query on data on to get the addresses. Right. So when you're using NoSQL, you'd have to keep these things in mind on what you want to do. So this kind of thing works really well when you have a lot more reads than writes. Because if your writes are frequent, then writing the entire document again and again or updating it might be a little costly. And if your document is getting updated very frequently, then duplicate data across your database will have problems, because you'd have to go and change a lot of entry if some entry gets changed. Like a small example around this would be around apna blog wala example, where let's say if I'm designing a schema for on top of MongoDB for storing blogs. So what I'll have a collection for blogs, and on blogs, each document will have a title, a body, author, and tags. Okay. With respect to author, I can have what? I have one author of my blog. Author has name, bio, and something else. Now, this is denormalized way of storing things. Correct? If I want to do it normalized way, what I would do, something that SQL teaches us, is to have it as a separate entity, call it authors, and author may you have author ID. Remember, with this, what would happen is if the data is denormalized, and let's say there are 500 blogs written by a certain author. Now, what would happen is once 500 blogs written by a certain author, and that author changes his or her name, if the data is denormalized, the update would just go into this one collection, because for at other places, it's just ID being referenced. Right. But if my data was denormalized, which means instead of having author ID, I'm actually storing this information. And if my author changes the name, I would have to go and change the name in all the documents, in all the blogs that were written by this author, because my data is denormalized. Correct. This is a major concern. So when picking a NoSQL database, always understand your use case. Like, do you want to keep data normalized or denormalized. It will depend on if how many reads versus writes do you have. If updation of author's name was too frequent, right? If it was like once a year or something, it's still okay for you to do it. But if it was too frequent, let's say every day author is updating something, right? Then this would become very costly because you would be constantly trying to update all the data for that author every day. Right. So think about these sorts of use cases when you are picking a certain database, and within that certain database, would you want to pick A versus B? Okay. One final problem before we take a break or something. We'll take a break after this. Is about n+1 problem. So this n+1 problem is a very famous problem in SQL world. If you have used GraphQL, GraphQL also suffers from n+1 problem. People have found few solutions around it, but what it says is n+1 problem says that this is a problem where someone was talking about this. Okay, what happened? Okay, when we were talking about users and we're not talking about users and addresses, and if that user has multiple addresses, you can fetch all of those addresses in one shot. Okay, where address in these IDs. But what if that is not given to you? What if in operator is not available and you have to like make one query for every single thing, right? So one query to get users and then n queries to get n addresses of the user. So this is a classical problem of n+1 queries. Most of the SQL systems suffer from n+1 problem that are ORM based, especially Django world. They suffer from n+1 problem. GraphQL suffers from n+1 problem, right? This is a little out of scope. If you can go ahead and read about it, anyway, I've fixed a lot of n+1 problem. I can help you with that. But go ahead and read about what n+1 problem is, and I'm more than happy to discuss. But might be a little out of scope. So if you'd want to discuss it anytime after the class, I'll be more than happy to do it. Okay. So go and read about n+1 problem in SQL, GraphQL, a lot. Every single database suffers from that. NoSQL denormalized data is a classical example of n+1 problem. So be aware of it. Chalo. We'll take a few questions and then we'll go on a break. And then there is something to cover. Okay, we'll do it. Yeah, Varun?
Yes, sir. I just have confusion regarding Mongoose. Like we have MongoDB, but when we work on Node.js based application, everyone prefers to use Mongoose, and it provides us the facility to link the different documents and all. So, but we know that behind the scenes it is actually using the real MongoDB NoSQL thing, right? So, do you think that it is a right practice to just think that okay, I want to create social network, let's use Mongoose, and in reality I'm using NoSQL, but yeah, Mongoose is providing me that kind of abstraction. So I just want to know the performance.
Start with Mongoose, start
aspect.
with ORM, you need developer productivity on day one.
Okay.
Once you optimize, once you reach that skill, then write your own NoSQL queries.
Okay.
Yeah. Sure. Yeah, Chandan?
Yeah, so with regards to that Mongoose that we talked about, and we are talking about the SQL joins, right? So even Mongoose, we have something called the lookups and aggregate where we can connect two documents and do. So even whatever we discuss will not work like that behind the scene, that lookup thing that we do in the Mongoose.
Check. I to be really honest, I don't know how Mongoose work because I've always preferred writing raw queries and not use this. I really am not sure how does this work, but if someone else knows and want to speak up, can do it.
Yeah, so I think there's another one. So yesterday we discussed about the stop deleting the rows we don't need, then doing a cron job. So let us assume we have a use case like recycle bin, right? So when you delete something from a computer, it goes to the recycle bin, then we delete there, unless you want to do permanent delete. So if I have some use case like that, I want to delete rows, but I don't want to permanently delete it from a database. So in that case, is it a viable option to delete from the SQL database, then keep that in a columnar database, which is write heavy and not read heavy, and doing that?
Why would you want to keep it on columnar? You can just store. Even a soft delete would work for that part. Why do you want to even move it out of your database?
because if no longer I need it, it's a very past record, like 10-15 years back
But
record. I don't
you're
want.
but you would always be so is your recycle bin for lifetime or will it auto delete after 30 days or something?
No, I for a lifetime.
So then typically one approach to this problem is malab, you can solve this problem twofold. First one is have this is deleted flag on forever and not running a cron job to delete because you are never deleting it. So let the data reside there. Another way is have a duplicate table and move this row from this table to that table. That's it. These are two approaches that I've seen basically working very well for people.
Okay, not keeping in a write heavy database. Take from.
Then you can archive it and keep it on S3 if read, but not on write. But why do you want to have it on write heavy system? You want to move it out of a write heavy and into a read heavy, right?
Yeah. Yeah. Sorry. Yeah. Yeah.
Read heavy is something that you are trying to say. But don't do that. That's an overcomplication. Matlab, if you are not making analytics query on that, why would you want to store it on columnar database? You just want to store it at a cheaper storage.
Yeah.
Correct. So cheaper storage could be S3. You can just define your own format and basically pull the data out, which is deleted true, and then store it on S3 for a cheaper access, and not let it hog the storage of your primary database. But if this deletes are too frequent, then only it would be worth it. If it's like you're deleting out of 1000 elements, one is getting deleted, then it's not worth it. For example, Google Drive. So Google Drive, when you delete something, it goes into a recycle bin. It stays there for 30 days and then it auto deletes it. Right now, if you see how many entries you create on Google Drive versus how many you delete, your deletion is not that frequent. And if a deletion is not frequent, what you should be doing is you should let it be there with is deleted as true. Right. So once someone goes into recycle bin, then he or she would find, so there it's like exactly the same query, but with is deleted as true. While on the main interface, it would be is deleted as false. Right. And then if you're running a permanent cleanup, then you do it. Otherwise, after 30 days, when you know that this is very infrequent access, then you move it to a very cheaper storage. If this becomes a pain point, then only. Otherwise, just keep it as is. It won't cost you much.
Thank you.
Okay. Yeah, Rahul.
So we just mentioned about the n+1 problem which SQL is facing. So first we try to query user database and then we query all the address one. So why isn't joining helps there? Or it's a different?
Join would help, na? Join would help. I'm
Like,
not saying no that basically join would not help. Join would help.
Like how is the problem? We have a joins then. How the n+1 problem came from?
Read about it. Why it would be there is because one example is lack of interfaces. So if you are using Django ORM, okay, users and addresses. So if you are using ORM, typically how that would function is you would have some sort of exposed function to fetch a certain entity. Okay, and that function would just take in one ID as an input. Let's say you have a function that gives you given a user or a user can then you have addresses. For the addresses, instead of taking in input as a list of addresses, it can only take an input a single user ID. So then what it would do is it would get addresses and then it would iterate and make that function call again and again to get those n addresses. If you're writing raw SQL queries, you can very well use joins. If you're using ORMs, all of these things are abstracted. You have to use prefetch, related, and a lot of other things to ensure that your ORM is not firing n+1 queries. This is a genuine problem. Just read about it. But that's a basically n+1 itself is an hour-long discussion if we go into depth. Why is that even a problem? If you have used GraphQL, that is like very prevalent key. That's on your face. The n+1 problem is on your face. Ye to hoga hi hoga. Right, so thoda sa, let's read it. We can obviously discuss it in the coming weeks. I'll be more than happy to discuss it. But just spend some time reading about it. Right? Fir maza aayega. Okay. Okay. Abransh, you had your hand raised. want to
Yeah,
ask something?
I had that, but this was around time series kind of a problem. So usually those are writes heavy, right? For example, IoT writing to that. In that cases, do you usually archive it or delete it in the
Archive,
longer run?
archive.
And
Older
what's
data is
exactly
typically
the strategy used?
older data is typically archived depending like if I was building a Xiaomi band after 30 days ka data mein aggregation basically fine granularity as time increases you would lose out on granularity. So you would keep like matlab, let's say for data older than 30 days I would not be showing you per hour data. I will only show you per day data. So you'll keep the data aggregated to that granularity level and keep it persistent in your main database. And that's how you'll start saving space.
Okay, understand. And even TTL is also used for that reason.
TTL for what?
Like let's say will not persist it in your DB itself, the main cache or whatever you call it.
Exactly. So you use matlab the things that are only the things that will be queried should be stored in the main database. Baki everything else should be archived. One fun fact
Understood.
for AWS for your Amazon's account orders. So you would see that drop down where you see that your past 6 months order, right? Amazon by default archives all the order which are older than 6 months into S3. So you would always see that 6 months wala order being served very quickly. Baad mein it takes very slow because it stores that other orders, your past orders which are older than 60 days into S3 to save money. And it does not store it in the primary database.
So again, so for that it queries to S3, parses the data and then
Parses the data and
then,
fetches it. Yeah.
oh,
And how do I know it? I wrote that code.
how do you know it? What? You have written it?
I wrote it. So I was part of the team who built this part. We pull the data out of a system, format in a form basically wrap it in an embedded database and store it on S3 and basically give it an ability to query it. It's a great optimization to save money. That's what hot storage and cold storage comes in. I was part of the team which built cold storage systems.
Okay, and that is where you said that you used to 15 petabytes of
15 petabytes of data. Yeah.
Okay.
Yeah. Chalo, let's take a quick break.
But just a final touch. So from S3, you are using something like Presto to query it? Presto or
No, not Presto. Presto would be too slow. We have a separate format. We will have some discussions around it. Not exactly Amazon specific because obviously that's a proprietary thing, but something around if you were to build a system like this, how should you think? And we will be having a very interesting discussion around this and next week or maybe tomorrow itself, I think. Mostly next week. Next week.
So one last thing, Arpit. So this will be a pura pipeline, right? So your project would have been a pura pipeline.
Yeah, end-to-end pipeline.
Yeah. So accumulate the data and then
accumulate the data, compress it, create embedded databases locally, then upload embedded databases on cloud. Embedded databases should be formatted such that we don't miss out on ability to query. See, the kind of queries you would fire on the main database is the query that you would have to support on S3. So that is even much more interesting. You know, how do we format it and all. So what we give them is without losing ability to query, we give them cheaper storage. The amount of money used to save for Amazon was more than $6 million a month. I never $6 million a month. Yeah. By just moving data out of hot storage, let's say you're storing data in MongoDB, we used to move data out of MongoDB and put it on S3. So the amount of money saved by doing this was $6 million a month in 2017. Up to it would have crossed around 10 million.
So you use query data on S3 directly?
Yeah.
Apit, one quick question: like, what kind of embedded database you are using to store that intermediate data?
It was a proprietary tech, but we will build a similar to that. Yeah.
Okay, I thought it was something open source. So I was just
nothing.
curious about it.
Amazon doesn't have.
Do any
Amazon
open
uses open
source.
source to give its services, but never uses it.
There's something that's been said on those lines. Amazon always takes the
uses
open
a lot
source
of
and
never contributes.
yes.
So just to ask one thing, Arpit. So basically, you told that the data would not be stored like on the real-time database and will be fetched from S3. So like still is a network call, right? Whenever the user wants to fetch.
Yeah, a network call, and that too a big one, because S3's latency were 15x slower than our main database latencies.
Okay, but like I'm not very sure how exactly because even in S3, like how exactly would it be a hot tier or a cold tier data? Because anyway, you like any customer would, let's say, want to see orders of 2017.
But then that order, but that customer would not expect that order to be shown on in less than 1 second. It's okay if that API call takes 3 seconds to respond.
Okay.
Correct.
Got
So
it.
what we are trading is we are trading time. We are still giving an ability to query the data, but what we are trading is we are trading time. We will give you a very cheap storage, but will have a very high access cost.
Okay. Okay. I'm not sure, but like I never noticed that it is that much expensive in like after the internet boom, which we see. Like I'm like pretty much sure no one notices like a 1 second or a 2 second difference, but it might be costful to the enterprise.
अरे बाबा, मैं ही बच्चा मतलब I was part of the team. I know कितना पैसा बचता था यार. Fun times. ठीक है. Let's take a quick break. Then we'll come into SQL, NoSQL, and sharding, basic around sharding, and then we'll build a real-time data store, like something like Firestore, right? And how to build that part. What's the most complicated challenge here, and how do we address it? Okay, इसमें you'll have a lot of fun. चलो, we'll see you at 5:30ish. Thanks, guys. Let's start the next part. So this is the most famous question, like basically when to use SQL versus NoSQL. One simple answer is there is no textbook definition. It's very hard to decide like matlab, when to use SQL and when to use NoSQL, because everything that you can do with SQL, you can do with NoSQL. Everything you can do with NoSQL, you can do with SQL. Lines are very blurry right now. But there are few things that could help you make a better decision. So you should be using SQL when you need strong consistency and integrity. Like SQL gives you foreign key constraints, check constraints, primary keys, on delete cascades, update cascades, and whatnot. So when you have this kind of things, when you need these kind of things, when you need transactions, you need ACID properties, go for SQL. NoSQL will never give you the kind of things that SQL will provide you. If you are doing real-time analytics, want to make a lot of aggregations, SQL does a great job, because NoSQL is sharded. Sharded to aggregation doesn't work. Well, work, but works very slowly. Right? So SQL has this kind of flexibility. So you should be picking SQL when you have this kind of things. Another classic example that people give it pure, if you have schema full, then go for SQL. Otherwise, no. A better way to put it is, if you want to utilize your schema well. Like for example, if you don't know the kind of queries that could come to you, right, then SQL does a very good job, because SQL pay you can create indexes and support any kind of queries, like with aggregation, key lookups, range lookups, sorting, sorting on multiple fields. All of these things is very efficient with SQL. On the other hand, with NoSQL, you can't do much. Data is sharded. Your query would just run on that one shard and give it. If it's cross shard, it gives you very slow performance. But when would NoSQL come into the picture? When your data has, when you want to inject custom things into your data, that's a NoSQL is very handy. When you know that most of the operations that you will perform will be around key lookups or basic minor pointed lookups or range queries, not a very heavy use case, but mostly around, if you can partition, or if you can foresight a partition that you would be doing on a certain parameter, then NoSQL would do the job. If you know that everything would revolve around a certain entity, and most of the queries for that entity would require that entity to be given, right? Wahan pe you will be using like NoSQL. That would do a great job there. And obviously, when you don't need acidity, when you don't need acid properties, go for NoSQL. Otherwise, SQL, by default, start with SQL. That works wonders. And then you can understand that these are like, so if you are just starting out to build a product, go for SQL. And this does not go for a startup that you're trying to build, but something while you're working at your company. Go for SQL, understand, because early days, products may a lot of things change, a lot of requirements change, a lot of analytics things change. And once you have a consolidated requirement, then you can spin off microservices and which uses specialized databases for those specialized things. Right. So always on day zero, day one, SQL databases would rule the world. But if you are building something on your own as a hobby or something, like I'm building platform for you guys for managing my code and all, I'm using DynamoDB. Why? Because Amazon is giving it to me for free. Right? Because if I use SQL database, it would, basically there is a cost associated to it. But DynamoDB is full free for, to a very good extent. It will not cost me any money. So then I'm just trying to model my schemas to fit into DynamoDB use case. Like, so having n+1 queries, my code is filled with n+1 queries, but that's okay. It's just starting out. Once I have money, then I'll buy a hosted RDS and then migrate the data. Right. So why I'm saying this? Because these are external factors which your engineer mindset might not think of. Like an engineer would say, no, for this use case, I want SQL because that would work the best. But there are certain circumstances where you would have to make that hard call and say, I don't have money. Let me use NoSQL. Okay, this is something that would always translate into your company, into your day-to-day work as well. Like certain conditions, like our team does not have expertise in managing MongoDB or like writing good MongoDB queries. Why do you want to write MongoDB queries? Or why do you want to use MongoDB for this use case? Right? What is something that this database gives you that other doesn't? So you need to do your homework first before you propose a new element in the tech stack. Okay. Nice. Then MongoDB, then NoSQL. The core feature of NoSQL is sharding. Few things about sharding. So horizontal partitioning is where you do a range-based partitioning, something that we have been discussing a lot, where a certain range of data is present on a certain system. Vertical partitioning is something where you are splitting data across columns, right? So data or across columns is one way, or across tables. So this is typically splitting of microservices, where all the payments related tables are stored in one database, all users related tables are stored in another database. So this is vertical partitioning, where you are partitioning the tables, right? So few tables residing in one database, few tables residing in another database, right? So this is also a limit. This kind of decision is also possible. So just making you guys aware. So this is nothing but splitting your monolith into microservices. This is where you would use it. Sorry, partitioning schemes, hash-based partitioning, most common one. The problem with this, so with hash-based partitioning, you would have a partition key, you would apply a hash function on it, you would take a mod n or something. The problem with this is when n changes, you'd have to repartition, or you'd have to do data transfer such that the data transfer, it takes in effect with respect to the new distribution strategy of yours. Right. So typically this is avoided when you use range-based partitioning. We will talk in details in future sessions about how to do data transfers, how to minimize data transfers using consistent hashing and all. And we'll see consistent hashing in action. Okay, how does it actually help us to do that? List-based partitioning is more like static assign, something that we discussed. Like from this to this is where it goes. Static assigned partition per value. So mostly like fixed partitioning, something that we discussed. This is exactly that. So when you want to implement multi-tenancy, fixed partitioning works really well. Then there is round robin. First goes here, then here, then here, then here. This is typically used when in load balancers, when you're doing round robin. With data, you typically don't want to do that, because then how would you know if my data lies in which database? So this is least used thing, but you might find some examples of this. Okay. Issues with sharding, obviously, joins. You can't make joins across shards. Your data has to be denormalized, referential integrity is gone, and rebalanced upon adding new shards in your system. Right. So sharding, although it sounds very good to scale and all, it has a ton of pain points. So you'll always need to be aware of that. Now coming to our system design. Like this way, what we'll be doing is we'll be building. Yeah, Umang, go on.
So just one question, like in real scenarios, like if we do sharding, does it affect low level changes? Like at a later point of time, you decide to shard your database. So
yeah, low level changes are.
So as in it affects the application, like rewriting the application too.
It does. Not entire rewriting, but a certain part of it definitely.
Okay.
Okay. So what we'll be building is we'll be building something called a backend as a service. How many guys? How many of you are aware of Firestore? Or Fire? Umang is there. Nice. Only one. Vamshi. Nice. Good to see that you guys are aware of such things. So yeah, what has happened was AWS gives us, what AWS gives us? AWS gives us like MySQL hosting, this hosting, that hosting and all. And these are like database servers that it gives us. Right? Now with backend as a service, so this is something that that companies like Google have started to offer, like under Firebase, Firestore and all, which gives you services as a service, like notification service, API hosting, security, email verification, authentication to multiple providers. So all of these things which are typically microservices in a traditional company, Google and a lot of other providers have started giving this as a service. So in one click, you can have a notification system in place. In another click, you can have a database in place, like directly image, audio, video processing pipelines. directly. You don't have to code anything, right? Everything is by default integrated into it. So this is nothing but backend as a service. So this is something that is minting money for these companies, but we'll pick the database like Firestore and see how it is built. Google Firestore is something, yeah. So the idea behind Firestore is very interesting. So what did these guys do? Is these guys, they gave a cloud hosted NoSQL database. Like you would say, "Arey, ye to Mongo bhi hai," right? But this cloud hosted NoSQL database is a very good one. What it does is it has storage, which like MongoDB bhi deta hai. What's new? It gives synchronization. So this is a great feature of it, that when you're building like a very small application, let's say you're building an application where you are running an NGO, you have a team of 15 people and you want to do a survey across a village, and each of the 15 member has a phone with them, right? And now what would happen is this database is, it gives synchronization, which means that an update made by one person on a database is broadcasted to all other 14 members. So along with it getting stored in the database, it also gets broadcasted to other folks. So this way what happens is their database across those 15 devices, they are in sync. Their local copy is in sync. Although they have a central storage, their data gets updated, but the update gets flowed to all other 14 members. So eventually you don't have to refresh and pull the data, it is pushed towards it. So you can think about it as a push, but implementation can be pull based typically. Okay. So this is where the basically this is what the lit feature of Firestore is, right? So apart from giving you performance, stability, reliability, peak the productivity and all, this is what the lit feature is. Like you have a real-time data sync between the clients, as in you are having real-time listeners of the data changes that happens on your database, right? Now this is basically kind of a diagram that would help you understand it. So you have customer C1 that made an update onto the database. Customer C2 and customer C3 were listening on the changes. Customer C1, customer C2, customer C2 and C3, upon C1 making an update, C2, C3 both received the update, right? Similarly, when C2 made an update, it was broadcasted to whom? C1 and C3. So everyone is a master, everyone is a listener, right? Everyone plays both parts equally well. So what if we want to build this thing? What would you use to build this kind of scenario, this kind of system?
On update, you just put it in some queue. I mean, whenever the data is updated.
A message broker. Yeah.
Whenever the data, I mean, there is a processing part where which notifies basically. I mean, that's the idea.
Okay. Let me start jotting things out. You said a message broker something, and then you would put it in a queue. What's exactly that? So let's say I have a user that made an update. It went to my API server. Now what would happen? You'll push this update into a queue.
First, the database will be updated.
Okay, database is updated.
And then we'll put a queue, put a task in the queue, which will notify all the subscribers.
How will my subscribers be notified? What kind of communication would you use here?
Either it will be, sort of pull. So you said that it can be pull or push, right? So if it is a pull, okay.
We can have WebSockets.
Yeah, WebSockets is one way. Server-side event is another, because we don't need server-side events is one way. I mean, whenever you just listen to events from the server, yeah.
Okay, let's start with WebSockets. Okay, because when other customers also make some changes, the person also needs to know, right? So typically, this is something like you put it in a queue or something, and so all other people connected to the same API server gets notified about it. Correct. Now, what have we discussed? We discussed that we want to use something like WebSockets to make it real time, because otherwise things cannot be made real time. Right. So you are also putting task in a queue, but if you put it in a queue, then the real time feature is gone. Now what?
Can we use PubSub model here?
PubSub. Like what?
Kafka.
Like what?
Kafka.
Kafka. But that is still a queue. It will take time for you to process the data and do it. So Kafka and queue, there is no difference typically. Basically, Kafka is also just a queue.
But in Kafka, you can serve multiple consumers at the same time as well.
So all of them would subscribe to this. So every one of them would subscribe to this same Kafka queue. So you are opening up Kafka connection to your clients.
Right.
That's wrong, na? That's wrong, na?
Yeah.
How about WebSockets, and instead of a queue, we cache it in Redis and like store it in DB asynchronously. That way, it could be some kind of a real-time thing. And since it's WebSockets is bi-directional also, instead of stream or a queue.
Okay, but then if you cache it on Redis, then what would happen? Let's say you have cached it on Redis. So you made an update. So let's say user A made an update, and I want B, C, and D to receive it. So what's your flow with Redis?
So it could be something of a write back cache, like it can store with there, then asynchronously updates the DB.
But then who will read from the cache? B, C, and D.
Yes, anyone who makes a request can read from it, and it can be some.
But real time would happen when the information is pushed to them. If they are doing a refresh, then what's real time in that?
Yeah. I mean, maybe have a worker behind the Redis queue.
But we discussed now. We discussed we want to have WebSockets.
Arpit, not sure, but how about an actor kind of a model, reactive?
But then that's still a WebSocket. Even if you have that, how will you implement this? So you have an update. Update goes to the database. Now this update needs to be broadcasted to B, C, and D. So we decided to use WebSockets.
Since BC and D are long polling, so can't the API server just new request comes in, update the database, and then update everyone else who's registered to it?
How? That's the question. How it would? So basically, you are saying that BC and D are long polling. I'm saying that BC and D are connected, but we decided to use WebSockets. Okay. If it's even if it's long polling, they would read this. So they would want to read the same data. But what would happen is, how about ordering? If you make a call to database, what kind of data do you expect it to read? There
how
has
about
to be.
Yeah, sorry, go ahead.
So then you would have to consume the data in certain order, right? It's not as simple as it sounds. It'll put it there, because now let's say A updated 3 entries in the database, spanning 3 different tables, right? And now these entries need to be communicated to B, C, and D. Where would we store it? Someone said Redis. So in Redis, what would we store it? How will you store this information?
I will
be like an append only log.
Append only log. New things coming up. Nice. Append only log. If we do append only log.
I mean, post inserting, can we trigger a hook from DB? Like it should send, some information to BCD like that.
Rather than directly from DB, when the Redis is updated, since it's in memory, it would be fast. You can trigger something like someone who's updated. Besides that, everyone gets it. Like A updates something on Redis and push that update to B, C, and D.
So how will you store this information on Redis?
As a key value pair.
So your key would be what?
My key would be the user ID. That way we can distinguish which user not to publish that data, because it's already.
So let's say user A. But then once the user A made some change, now when you are doing some operation on that, this would be replacing the value. So one user making 2 requests, the first one without even reaching to BCD got replaced.
See, can you use sorry, like, can you use another table in DB, like when user made an update, like we will be having ID. So we'll keep on status like pending updating like that. So once it is completed, can we push to BCD? So meanwhile, if A update, I mean,
So
A
you're using DB table as a broker.
yeah, indirectly.
It's
So basically, we want a group chat, right?
Now we are talking. Correct. See, this is
Something
exactly
like
what you
room.
should be thinking about, right? What is this problem very similar to? This is nothing but a group chat. This messages are nothing but a database updates. Correct?
Yeah.
Now, see, most of the system design things is just about building those analogies, and that is why I just started. I just let you guys brainstorm, because I know someone would just see, "Arey, this is nothing but a group chat." And now think about how group chats work. Now, what would happen is this kind of architecture would also work with what? Group chats. So, ek tir mein we are shooting this three birds in one shot. Okay. Chala.
Group chat में probably WebSockets are there and UDP is there, right? UDP,
TCP.
I'm not sure, but yeah.
TCP,
right?
It's a persistent TCP connection. Yeah.
I mean, I'm not sure as to how group chats and how that communication works. But yeah, somewhat we need to do a group chat. When I send a message, it should be first stored to DB and then it should be broadcasted to others.
Yes.
So what if whenever A is writing a message, we write it in the DB, and we kind of have an append only log in Redis or wherever. There we kind of make a new entry, like sequence number with what the change is. So whoever the clients are, they can check what the last sequence number they're updated with. Whenever they get like a push notification from the API server, and then they can pull as many entries as needed.
Okay, that's a little detailed. Great job, Kaustubh, there about having that append log with a sequence number and everyone noting ki kahan tak ke they have read, and they can read something forward to that. That's a great way to design it. As a little in depth, malab, if you're building the system full-fledged, you will definitely need that kind of behavior. But to keep things, to keep things very strict, so we will be discussing that when we will be designing Dropbox. That is where a great use case of that thing is. But let's just restrict this discussion to, how do we fan out? Because let's assume that all A, B, C, D will always be online and all of them are connected on WebSockets. Once someone publishes it, other people should receive it. Right? But the points that you brought up are very relevant. We'll be talking in depth about it in week 8, first day, मतलब Saturday week 8 वाला day. उसमें बहुत मजा आएगा तभी.
Okay, so this is sort of a vague one, but WebSockets do have something, some concept of room, right? So what we can do is we can have the room ID as the table ID, like the ID of our table. And whenever someone pushes data to it, we can find the room, like the table ID, and we can publish it to that room. Yeah,
correct. Room and broadcast. So guys, you all have internet. You can quickly Google and see what all we can use, right? And always it's not so, it's basically not a question answer thing. Like you have to be correct. You can obviously hunt for things on the internet because you'll stumble upon really interesting part. So WebSockets are typically implemented by what? WebSockets are typically implemented by Socket.io. Okay. Let's say we are using Socket.io to connect my mobile devices. Let's say I have few of my devices, A, B, C, D, each one of them have mobile devices, having an SDK on which Socket.io library is running. Okay. Whose job is to manage, maintain socket connection. If connection breaks, reconnect it to thing. Now, what typically happens is when I have something like a Socket.io, what would happen is they would all connect to one server. So I would have one API server, and on that one server, all of my clients would connect. So my A, B, C, and D would connect to this. Now, what would happen here is when I'm writing my code on Socket.io, right? I have access to only the connections that are connected to this server and not other servers. If I have fewer set of users, and let's say all of those users are connected to one server, then this solution works really well. So the code goes like this. Code is very simple. So you do is on message, or basically whenever you're getting a request to, let's say you are making data pay, you are making a post request which updates something. So the job of this is to store or update data in DB. Once the data is updated in DB, what I want to do it is I want to find the room, and this is not hard. Find the room. Basically, all the socket connections which are connected to this room. So this room is very similar to a chat room that you have. Okay. Find room on which I want to broadcast. And then I do a broadcast on that. The limitation of this problem is this code will be executed on one API server. Correct? This API request came to it. I have a load balancer. Load balancer forwarded this request to one of the API server. So this one API server, but this request came in, and this code is being fired on that one API server. And on that one API server, I have room on which people are connected. Okay. And on this room where the people are connected, it will send the data to only those set of users. Right. So if I have two API servers, let's say I have A, B, C, and D, but D is connected onto different API server. So this is API 1 and this is API 2. Now, let's say A published a message. This message went through the code that we wrote down below. So it stored the data in the database, and obviously both the data, both the API servers are connected to the same database where the updates are flowing. Okay. Now what would happen is A made a update through this API server. API updated this. Now when this code kicks in, it would find a room. Obviously, room is there in one local memory. It has a bunch of TCP connections pulled together. Finds this TCP connection is connected to this room, and on that room, it is doing a broadcast. But while doing that broadcast, my message would be received by whom? Just B and C, right? Because the message has never gone to API 2, and my D will never receive the update. So when I just have one server, it is very easy for me to configure the system. But when I'm spanning this thing across multiple servers, this becomes a challenge. Now, this is a problem with an example that we're already talking about, something like Firestore. But think about it, if you're building Telegram or WhatsApp or any group messaging service, how relevant this problem is. Like basically this problem could be boiled down to scaling WebSockets. And how do we scale WebSockets? Right. Now you guys understand the problem. But the problem is when you have multiple servers, broadcast on one will not let people sitting on other servers know about it.
So Arpit, a very naive way to solve this would be based on the table ID, right? So we can load balance like we did yesterday, like A to M and N to Z. We can have different API servers, and with respect to the table ID that the users are joining to, we can send them to the specific API servers.
But
they
that
always
API server has a limit. Well, you can't have everyone connected to just one API server, right? That would become somewhat a choke point. At some point, you might have two API servers. Like, let's say your Telegram supports 5,000 people. Do you want 5,000 people connected to just one API server?
No, so again, it would be like in the when we are generating the tables, right? So it would be in the round. Let's say it would assign. Okay, it would be in the sort of like a round robin fashion. So we would assume that the IDs that we would generate, that we would be generating, the very first one go to the API 1, then the second table would go to the API 2, the third one to API 1, and so on and so on and so forth. We can try to do that.
But
like,
still,
am I clear?
the problem is still with the broadcast. No? People from API 2 won't know about what's being broadcasted from API 1.
No. So what I'm saying is, so because for this example, if you want to send the broadcast to D, we want, because A, B, C, and D would be in the same table. So what I'm trying to do is we are sort of ensuring that everyone from that are connected to the same table would be on the same API server.
That's not possible at scale. That's what my concern is.
Okay.
Matlab, you might, like, let's say you are building YouTube chat. YouTube pe there are a million people watching a video live and they're chatting. Would all of them be on just one API server?
Yeah, makes sense. Okay.
Right. So if you try to extrapolate the problem to a massive scale, you will find use cases where companies have solved this problem. Like while I was architecting chat for live classes at Unacademy, we stumbled upon this very problem. Right? Because everyone is connected to sockets, everyone wanted real time. And basically on the chat, there is a question, okay, how much real time do we need? So we need exact real time. So think about it that we are chatting. So we have a Telegram group of about 10,000 people chatting at the same time on that group. And not all of those 10,000 people can be connected to one server, because then you might have you might have a very heavily over provisioned server to even just cater to one or two people, because you would need to have homogeneous infrastructure. So there are too many limitations when we think about it, when we want to restrict all the people to join to just one server, right? So now if you see our challenge now, there is another question. Yeah, Ankur?
Arpit, since all users are connected through the WebSocket, we can get their IP address and we can cache it, and then we can check in our list who all are available right now.
So you would have a separate list where all the people connected in a room, the IP addresses are there.
Yes, some sort of.
Still not a great solution. Because with IP addresses, with sockets, and then doing an IP lookup and then sending the data back is a little tricky. And then new member joining in and list not getting updated, that person will not get any updates. A
So,
lot of edge cases needs to be handled. Yeah.
How about we have a, like, whenever a client connects to a server, a WebSocket is opened. So we can cache this information in some central server, like, like a WebSocket is an active two-way communication channel, right? So whenever there's an update happening, so you process the update to the DB, and there's another thing. So that will actually query the data, like, the central repository where the clients are connected. So through that, you can reach out to the API servers and then broadcast it through those
Which
sockets.
API servers to reach out? See, that is the problem. Which API servers would you reach out? Would
No,
you
that-
reach out to,
no.
let's say you have 1,000
No.
API servers.
No, that's what, like, for example, I'm a client connected to a app node A. Assume that I'm connected to node X1. Okay. So I'll store this information in some central repository. So my processing engine will take care of like checking this node. Suppose whenever there's a termination on the client, like, we know that, like, okay, we know this, like all this, like whatever you told, right? Like it's a group. I know that all these nodes are connected. It's like, you just query on the key, and you know that if the app node is down, so definitely the client is not connected to it anymore. There would be like, again, the client will try to connect to another app server, and eventually that will actually update the central repository. So that is also one way, right?
That is one
Do
way.
you
But
see
then,
any problem with this?
no. But then with respect to your broadcasting from your central repository, so the API server which got the request to make an update on the database, that API server would have to iterate onto the cache to get to the list of all the users that needs to be sent this broadcast.
Okay.
Right, and from that you will be reaching out to the corresponding API servers and then talking about it. So then typically you need to have API server to API server level communication.
Okay. You don't want to have that
No, why not?
internally too.
You'll need that,
Okay.
because otherwise how would
Yeah.
D know it? But
Yeah,
how would
exactly.
correct. Now hope you guys are also following. So now the problem is, how would D understand that there was an update sent from A, right? Which means what we need is, we need communication channel between both API servers. So API server 1 and API server 2 should communicate. So update going from API server registering the update in database, coming back to the API server when it is doing the broadcast. Doing broadcast on B and C is easy, but then it also has to tell API server 2, array, you have D connected who is also listening to the same table. So go ahead and publish this message to D. Right. This is the crux of the problem. So this is exactly how WebSockets are scaled in real world. So server to server communication is how you can avoid, like you can avoid having that constraint that all the clients should connect to the same server, because then only I can have broadcast. Right. So now if you have multiple servers, multiple tiny servers running, you can have an inter-server communication, and we'll exactly look how to do it efficiently. We'll have an inter-server communication happening that tells ki, A has made an update, D is sitting on API 2, let API server and API server to communicate and say ki, go ahead and tell D ki this update is made. Right. This is what the core problem is that we have to solve. Now, what do? We use Redis. But how is we use pops up. So the that's why I've ensured that I've noted down all the key points. I've noted WebSockets underline, Redis underline, pops up underline. This is exactly what we'll do. So how the problem of server to server communication is how we are solving it, because if we do it naively, then every server needs to have a certain port open where any other server can connect and put out a message to it, right? That's a really tedious way to do it. And then you would have to, if you do it on your own, you would have to broadcast message to all the API servers. But how to do it efficiently is somewhat you are using Redis. So what Redis gives us is Redis gives us pops up. So it has a command called subscribe. It has a command called publish. It has a command called unsubscribe. So what Redis will do for us is Redis would ensure that all of these servers are connected to a central Redis cache. Okay. On that Redis cache, there is what? There are so all of the servers have the TCP connections set up with Redis, and they have published and they all have subscribed to corresponding channels. Let's say for each table we have one key. So subscribe ke argument pe you can give it any key. Let's say that key is nothing but a table ID. Okay, so subscribe to this table ID. Who will do it? All the API servers would be constantly subscribed to all the updates there. Now what would happen is when the publish would happen on a certain key and with a certain message, right? So now once someone publishes something, all the subscribers get that message in real time. Okay, now why are we using Redis for this? Is because Redis, number one, gives us scale, because Redis can operate in cluster mode. Number two, Redis will ensure that if my TCP connection between my API server is broken, it would automatically reconnect, so that we don't have to manage the connections on the road. Number three, it would ensure my TCP connections are long running. It has done all the heavy lifting of networking protocols on our end, so we don't have to worry about it. We could have built a nice solution on our end, but obviously let's talk real world situations where would you build something on your own versus just something which is already there, right? So Redis is already giving you pops up with real-time distribution of data. So now what do we do is given this thing, the way we solve our problem is, this is exactly what we discussed. So I'm not skipping anything. It is about key value store, updates going here and there, concurrent connection space scaling and all. Languages that we can use is something that is supported by Socket.io. Tech stack, in-memory database, Redis backed by Mongo or something. It's just something that we all already discussed. It just I just basically wrote it over here. So the the first one was about simple architecture where you had user A, user B continuously polling about it. This is the naive way to do it. All users connected to the database, poll for the values updated, and they get all the data out there. Right. So this is one way to do it using append on the log, sequence numbers and all. But if you want, but this is not real time. And long polling is there. But what we want is we want near real time where updates are pushed to the clients directly. This is exactly what we have discussed. Now, what do? Is we this is what the first problem is. This is what we discussed. Okay, we have socket IOs on client A, client B, and on the server we have a connection pool, and this connection pool has all the TCP connections pool which are subscribed to a certain room. And once the broadcast has happened, it would just broadcast within that pool. and it would not go to other servers. So Socket.io on server manages a connection pool. When requested for a broadcast, it loops through the connections and sends the message, right? But then it is all local to one thing, right? So that's when the main problems are there, which is something that we'll be discussing. Just give me a minute, I'll take a question. Yeah, Umang?
So, like, I just wanted to ask one thing. So, you brought this out as a separate topic called real-time database. So, does traditional databases do not allow this functionality, or
Which functionality?
like the real-time thing?
They give you real-time thing. All the updates are real-time in sync on your devices.
No, like, I mean, you specifically brought up the point of Firestore, which is a real-time database. So, like, PostgreSQL or MongoDB do not give this functionality, or
no, they don't. They don't. They don't.
Okay.
On MongoDB, you have to fire SQL queries and then you'd get the update. Na? So anyone who wants to get the data, let's say customer A wrote a data and customer B and C is making the API call to read the data.
Yeah.
Right. But here what would happen is all of them are connected to that same database table. Any updates on the table are automatically streamed down to them.
Then like there should be some downside for this, right? Like, but
yeah, not scalable, not recommended in production usages. It's very niche market, for a very teeny tiny applications, for very basic use cases. This is
okay.
This is not meant for like production grade SQL engines and all. No, not for that.
Like
very specific.
So like even for like let's say Zerodha's case, there would be a WebSocket open.
This is not Zerodha. Zerodha would never do this.
Right. So this is just for small applications and not for production.
Very small applications. So that's where I took example of that NGO where having a team of 15 members trying to do this. But a solution that we are discussing is extensible for any group chats.
Okay.
So if you are building WhatsApp group chats or any chatting application over WebSockets, this is how you'd scale it.
Okay.
So this is yet another building block that you can use to build things around. Okay. Yeah, Sanjay.
Yeah, just my question was one clarification on the ordering of the messages, because if you broadcast to your own, if the API server broadcasts to his clients and then publishes to the pub sub, and another there's a concurrent write, there's a chance that the clients can get, depending on which API server you're connected to, you will get different orders. So it's better to probably just write everything to the pub sub and allow the pub sub to order all the messages.
Yes, definitely. So ordering is a problem which can be solved separately. So that's what we be listing aage in next couple of slides. I've written the ordering is a problem which needs to be addressed well. So these is not really a very production grade, not meant for like thousands of concurrent users doing a lot of things and all. But obviously you can make systems better. This is about understanding that building block on if you want to scale a certain thing, what kind of things or what kind of tools you can use. Like for example, in this one, what we learned about is Redis gives you PubSub, which you can use for inter-server communication to do real-time communication between servers. By the way, this is exactly what is being used by if you are using Python and you have used Celery as a framework. So Celery pe worker communication and they use gossip protocol between them through Redis PubSub. So this is something that you can use or you can leverage to have inter-server communication between our API servers. Yeah, Pradha.
So this might be a slightly off-topic thing, but the whole system that we build, right, for the NGO part, this can be very similar to a like or something like what Twitter does, or it automatically updates the like count when we pull out a tweet,
Yes,
right? Let's say.
Yes. Go be. Yeah.
Cool.
So all of them. So basically, users are connected to a certain post or something, and once the like is there, it is broadcasted across.
Yeah, so that's why it on real time it automatically
real time
updates.
it basically updates the tweet count. So you can use similar architecture to build medium claps.
Yes. Right. That's what clicked me. The first class one.
Yeah.
Okay, thanks.
Yeah. So here, if A and B, A, B, C are connected to API server 1 and D is connected to API server 2. So when A publishes a message, the API server 1 will receive it and it will broadcast to B and C. So then the API server 1 will be publishing it to the channel, and then API
server 2
2
will receive it.
Okay, and then it will see. Then it will have to check the message, right? As to this message is intended for.
Yeah, definitely it has to. Definitely it has to. Malab, those all checks would be there, obviously. And it's more about basically looking things from a bird's eye perspective.
Okay. Yeah.
So let's dive into the solution. You have anyway summarized the solution, but yeah, let's just dive a little thoda sa deep into it. So how do we scale this architecture to support thousands of concurrent users? Is basically that's what the problem is. So you need more API servers. Once we have more API servers, each server has a local pool of TCP connections. Like my S1, S2, S3, S4, each one of them has four people connected to it: A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. Right? So these 16 people are connected to it. Now the problem was that A has published something, but I want E, F, G, H, I, J, K, L, M, N, O, P, everyone to know about it. So that is where we need inter-server communication for that. So that is where our Redis would kick in, something like this. So whenever a message or any update is being done by API server onto the main database, from that main database, it would first do a broadcast to whom? It would do broadcast to B, C, and D. And then it would publish a message on your Redis where all the servers have subscribed to a certain message or to a certain key, maybe a room ID or a table ID or something. And from that thing, my servers S2, S3, S4 will receive an update. We'll say, okay, array, one message is published on this channel. Let me broadcast it to you guys. Now, from once the message is received by S2, S3, and S4, it will see, array, I need to forward this message to people connected onto my server. Chala, let me do that. So then it would go through the local connection pool and it will forward it to E, F, G, and H. Similarly, S3 will forward it to I, J, K, L. And obviously, basic checks around it, who should get it, who should not, and all is there. Right? So that is not going anywhere. Okay. So the flow is when A has an update, request goes to S1. After updating the DB, A wants to broadcast to all. Local socket IO pool has A, B, C, D. So broadcast only happens to them. Other people don't receive it. We need S1, S2, S3 to communicate between each other. That is where our Redis PubSub comes into the picture. So now what each server will do, each server would store the data into the main database, broadcast it to the local pool, and publish a message on Redis. Once the message is read by the message, once the server receives the message or update on the PubSub, which is configured on Redis, it would broadcast it to its local pool. And this way, message from A goes to all participants, even if they are connected onto a different server. And this is typically how we would scale WebSocket based applications. Right? You can build Firestore, small applications like Firestore on top of that, chats, normal usual chat application. You can build Medium claps, Twitters, any real-time page communication happening where multiple users are chatting in a room or something. You can build and scale systems like this using this application. Yeah, Sugata?
Yeah, I had a question. So this architecture looks great. I had a question about the database and specifically around geospatial. So I wanted to understand if you had these messages that are being sent into the main DB. Perhaps you're partitioning it based on, like we were talking about, as like database updates. So maybe the specific database table could be represented as like the sharding key. But what happens when you want to shard it based on like these servers can all communicate down to the Redis client or whatever. So how does the main database get split across different geospatial indexes or like sections? And then like what would the database model look like, and how would that affect our implementation here?
Okay, so great question here. So when your database is split across geography, the communication has to go over a different channel. So that communication typically goes to us through a slower channel. Obviously, it is not a persistent communication. So that communication typically happens through message brokers. So we had to implement something similar to that. So we tried implementing it using Redis, where one Redis from, let's say, US region was connected to another Redis using PubSub through this, but that connection was very slow and the TCP connection broke quite often. So that's when what we decided to use was, we decided to put in a queue in between. So updates were flushed into a message broker, something like an SQS queue. From that queue, we had a consumer listing. So we basically connected different geographies over message brokers within the same geography using real-time TCP connections. Through this, what happened is we ensured that a certain geography, because that's what typically happens. People from a certain geography interact a lot, and the TCP connections are very reliable as compared to TCP connections over the transatlantic line. Right? So that is what we leverage. Inter-geography communication happening through broker, one consumer reading, and then publishing the message onto Redis, and all of them connected to its own local Redis cluster. So every geography has one Redis cluster, all the servers connected to the Redis cluster, which is central to that. Similar architecture across all geographies, and multiple geographies connected via message brokers and a bunch of workers which are consuming message from them.
Got
And,
it. So the idea is,
Hmm.
if I publish a message in the United States and that I wanted that message to be propagated to India, there would be a queue that collects all the messages inside of the United States queue, and then there's a broker or there's a subscriber in the India region, and it subscribes to that queue. It picks up all the messages and then broadcasts it to its local set of
to its local,
like
to its
okay.
Redis, to the local Redis of that geography, and then it basically broadcasts it to all the people.
Got it. I do have some questions around the partitioning around the queues, but I'll save that for later.
Yeah, sure. No worries. Yarana?
So in this, like asynchronization data replication data will happen from Redis to main DB, right? From time.
Synchronization of what? Can you repeat that?
From Redis, the data will go to main DB time to time. Like there will be a job.
Why? Redis is just acting as a pops up. Redis will not have data. Redis is a pops up. So Redis will only maintain our TCP connections across API servers. So S1, S2, S3, S4 are connected through Redis to each other.
But it indirectly, like it has to store the data, like it has to store the data as well, right?
No. It won't store the data. Once message is published by one server, it will automatically get broadcasted to other three servers.
And then what is the role of main DB like here?
वहीं पे तो store होगा ना. So once the data is updated on the main DB, then this process kicks in.
Okay.
Otherwise you lose the main persistence. So one update happened on the DB, right?
Yeah, like what I understood is like first it will like update will happen on the DB and then everything to Redis.
So first update happens on the DB, then the server broadcasts it to the local pool, then it publishes a message onto Redis, and then the subscribers of the Redis will get the message, and then they will broadcast it to their local pool.
Okay.
Any other question, Rana?
No.
Yeah, Varun?
Yes.
Sorry, दो वरुण है. बाद में लेते वरुण पराशर तो थोड़ा बाद में.
Okay. So my question is, like, we are talking about real-time communication. Actually, there is some kind of confusion in my mind. Like, what is the real definition? Like, you are saying near real time. Sometimes we are saying real time. Now, if we are including Redis, then also I can see that, okay, A sent update, B, C, D will get it quite frequently, right? Then there will be Redis communication, and then from Redis it will be broadcasted to S tool, right? So we can assume there can be a lag also, right? So do we still say that this is real time, or we will say that near real time for different server if there is Redis in between?
So you cannot have a true real-time communication because time always moves forward, right? You cannot have a true real-time. Your definition of near real-time would have to be what lag, what's that maximum lag that would help you define this is my real-time communication. Let's say WhatsApp message with a lag of 2 seconds is a real-time communication for you. If your messages are able to be broadcasted within 2 seconds, it's still a real-time communication for you. But if it takes more than that, then you will get classified as near real-time. So this definition is a little vague, but it depends on the use case that you are building.
Then there can be a problem where like someone said that, okay, there are two different geographical locations, right? And there is a change and someone is getting. What happens if due to this lag someone again updated the same value?
वो तो
Then
conflict resolution आएगा, उस पे आएगा भी conflict resolution
okay,
आएगा, खत्म नहीं हुआ है, आएगा.
okay, that is interesting. Thanks.
Yeah, Vishal.
Yeah, so my question was, do you guys use this sort of architecture in your on-academy chat thing, or something different?
Yes, this one.
This is
yeah.
Okay. So, but again, this will have a limitation, right? Of because as I've read, I'm not sure if it's correct or not. The pop sub of Redis also has limitations when number of subscribers and publishers increases to some extent.
So that is where it is limited by the number of servers and not by the number of users connected. Correct. So still it's a much smaller problem for us, because the number of servers would be like 500, 600 servers. That's still okay for one Redis server.
Okay. Yeah.
Correct. Because not all users are connected to Redis. Users are connected to server is connected to Redis.
Okay.
Right.
So what is the scale that you have seen?
We have concurrent 50,000 users chatting. We have
the group chat
around 100. We have around 50 servers running chat.
50 servers for chat, and they all are connected to one Redis PubSub, and then
one Redis PubSub.
Yes. In a one group chat, 50,000.
One group chat, 50,000 concurrent users, and we have about 20 such group chats in progress at a single point of time.
Okay, and a lag of 1 to 2 seconds max.
5 seconds. We don't really care about the 5 step. Basically 5-10 seconds tak jata hai. We because this kind of architecture is very costly. So we have to keep our resources down. So we basically buffer a lot of messages and then we sample the messages and send.
Okay.
So thoda sa we basically do a packet loss sort of thing.
Okay, got it.
Yeah.
Thanks.
Yeah, Varun?
So when you are talking about multiple geographies, you said you use an SQS, but isn't it ideal to use the event hub sort of thing? Because you have to ultimately send it to multiple regions, and from my view, event hub sort of thing makes sense.
Agreed. I agree with your point, but what we saw was a massive TCP connection drops there. We found message queues quite reliable because they didn't have a real-time communication channel set up between it. That's the only reason why we went for that. It seemed like a very hacky solution. Now there could be a better architecture. I'm not denying that. But when we were building this, we saw a massive TCP connection drop. Matlab, the TCP connection was so flaky that our TCP connections were mostly like doing a long polling. So instead of that doing a long polling, why don't we itself do it using message brokers and have a lot of parallel consumers who are consuming from that message and basically giving us a good real-time solution for that. Because because on TCP connection everything is synchronous. On a message broker, you can very easily fan out things. So across geography, instead of having one consumer, we have multiple consumers running, which can read the message and can fan out in parallel. So a little better thing that worked well for us might be very specific to our problem, but it is exactly how we thought about it. Having one TCP connection was actually creating a lot of problems.
My point was, instead of using SQS, use a kinesis stream. That's what my.
That's one and the same thing. SQS fan out use karo, kinesis stream use karo. That's exactly. That's not big of a difference. We could have easily used Kafka. We could have easily used kinesis. We could have used SQS. But since it's about one message being published, that message being received, and then some processing that needs to be done, you can do it with Kafka, because with kinesis and Kafka, you get persistence. We didn't really want persistence when the message was consumed. Right. So that is where we went with SQS.
Oh.
Yeah, Varun.
Yeah. There is another question. I'm not sure if it is relevant, because when I was once exploring about microservices architecture, they were saying that okay, servers can communicate with each other via RPC calls. Now I have two questions. Whenever we are saying that okay, Redis server, it means that server 1 is communicating with Redis server via a network call. Similarly, RPC call is also via a network.
RPC is also network call.
Right. So I just want to know what is the difference, and are these the two different protocols that they are using?
पढ़ लो इंटरनेट पे मस्त रिसोर्सेस पे मैंने रिसेंटली पढ़ा इसमें बोल रहा हूँ थोड़ा गूगल करो you will find more things around it. If I give you the answer you might not do it. थोड़ा देख लेते हैं बाद में we can discuss.
Okay, I will explore that.
Yeah, thanks. Sure. Now that we discussed about this, what's the biggest challenge here? Everyone like everyone is saying, "Arey, what about ordering? What about?" Exactly, that's the problem here. So with respect to database as a use case, there is a problem of multi-directional conflicts because now what is happening is everyone is acting as a master. If you build a use case like this for database, where we have 15 people, 2 people might be updating the same value in the database, right? So this is multi-directional conflicts, which is a genuine problem here. Another problem is ordering, like one message first and then another message, and then but the way it is being sent to the user might be a different order. So typically you would have seen on LinkedIn, the messages, they sometimes just change the order, right? So that's because of, lack of ordering. So typically what happens is once a message is published by an API server in the database, it is assigned that timestamp with the message. Or with the actual message which is being sent to be broadcasted to other users, and that timestamp is used at the client side for ordering things. So what would happen is, first let's talk about conflicts. With each client acting as a master, problem is similar to master-master replication, basically multi-master mode of SQL, where you have conflicts, both got update on the same row. Now what would happen? Approach number 1, either do old one wins or the new one wins. Pick a strategy. So depending on what kind of system you are building, you can pick a strategy. You can say that the one with the latest timestamp will win, or one with the oldest timestamp will win. It will depend on what you want to do. If you're doing raw ordering, then you would say that I'll be using this timestamp field, whatever it is, for me it is the source of truth. Okay. Approach number 2, you can show merge conflicts like Git and let clients fix the things manually, right? Might not work with Firestore, but if there is a major conflict, then you can ask users to, resolve that conflict, have all the states possible, and let the users decide which one to choose, right? So this is another approach to do it. Again, depending on the kind of use case you are building, you can have this thing. If you are building a real-time collaboration platform, right? Let's say you are building Figma, or if you are building Google Docs, where multiple people can edit the same thing, this problem also exists there, right? Multiple people connected to socket, updating the same sort of content. How do they do it? So there is an algorithm called as differential synchronization that helps us solve this. So there is a great talk. I'm still unable to comprehend that part because the guy who built that thing is unable to explain it well. I tried listening it 5-6 times, got sleepy a couple of times there, but I'm still trying to understand it from the research paper because that talk did not do a great job. But yeah, you can read about it. There is an open video, paper, everything about it. Google Docs synchronization or differential synchronization. You can read about it. There are multiple ways of handling conflicts. Depending on what you are building, you'll pick one over the other. Right? If you are building database, you would always say latest one wins. If you are building a chat sort of service, you say that the timestamp associated with this would be how I'd be doing the ordering of things on the client side, because then data updation is not really a challenge, but data ordering is a challenge. Right? So depending on, again, your system, you'll pick approaches there. And yeah, that's it. Any questions?
So like I just saw basically how YouTube live chat is working. So like I see on the network tab, every time there is one particular API which is being which is a post call being made. So shouldn't it be a get call? Like I do not understand. Like
I'm not sure. I never saw that part. मैं अभी try करूँगा definitely. आज ही live जा रहा हूँ, आज ही try कर लूँगा मैं. I'll do that. Yeah, Ronak?
So I have one question: like you are using this Redis just as a PubSub model to broadcast the message. So
this is a PubSub model to have inter-server communication to broadcast the message.
And you are not using Kafka because you don't have to store the message here.
Yeah, exactly. We don't have to store the message. So the message is anyway stored in the main database. Yes. And then what we only need to do is we want to broadcast. So something like YouTube live stream ka chat being streamed to all the people who have joined the live stream.
Yes.
Right. So message is once stored in the database, and it just needs to be broadcasted to all the people on that same page.
And here we are communicating with server only, so our like everything is proportional to server and not users.
Yes. Great point. Great way to put it. Yeah. So the scale is proportional to the servers. One server, there could be multiple users connected, but our scale would be mostly proportional to the number of servers that are there.
Right.
Yeah, Brancho?
Hey, in this setup, right, there are chances that packets could arrive late and so on.
Yeah, ordering problem. Hai.
Okay.
That's the
In that
problem
case,
now.
this is flagged.
But obviously the solution to that problem is if you are using FIFO sort of thing, because over one TCP connection, everything would be a FIFO. Right.
Yeah.
So in that case, the messages received by individual, if let's say we're building group chat, messages received by individual users will always be in order. Correct? Because everyone is connected to TCP, and the loop that would be run to broadcast it would always go from 0 to n, and the position of the corresponding TCP connection would always remain the same. So for a certain thing, since everything is FIFO on a TCP connection, the way the message would be sent to individual users would always be in order. A little misordering might be there. A little misordering might be there. We have seen it, a little misordering, but that's where client side sorting on the basis of timestamp works.
So in that case, do we, freeze the time window within which the message should be received? And let's say if packets are receiving after that.
If your use case is like that, you can do it. Malab, it all depends on the use case. Malab, there's no one solution for this. If your use case says that you would have to freeze the window and after this message should not be accepted, then you can do that.
Yeah, sure.
Yeah, Prabhat?
So in this setup, when one user disconnects for some time and then reconnects, then it will
That's another problem.
we will.
That's where Kaustubh's solution would work the best. Where Kaustubh suggested to have an append only log with a sequence number. Every client would need to know that, okay, I have messages till this time. So, when you have internet disconnected for some time and then you reconnect it, WhatsApp shows you this message, checking for new messages. Kya karta hai tab? What does WhatsApp do during that time? It says that, okay, I have message till this time. Give me all the messages that have been sent to me after this.
But in this setup, like we are not persisting the message in the Redis, right?
Redis mein nahi, but we are persisting in the main DB, so that call will go to what? Main database.
Okay.
Chalo. Yeah, Varun?
Yes, it is related to authentication for WebSockets, like how it actually works. Is it like, okay, once I do it for the first time?
Google. Actually, what WebSockets, there is no authentication. WebSockets is created on trust. You want to create, so someone initiated a web connection, WebSocket connection. You can have some manual protocol defined, but if your server has exposed a port, anyone with a WebSocket, anyone with a WSS protocol can connect to it. And once the connection is established, you might have a handshake. When someone is asking for some data, you would say that I'd always need this token to be sent. So this is typically done using JWT tokens.
Yeah, that is fine. That is what I am saying, that every time I have to verify that token, and then obviously there will be a speed issue and all, right? Okay, that we have to do it, or we can do the authentication at the first, that okay, authentication is done, then connection is open, it is fine. If I am more possessive about it, I can send the authentication token also, then I need to verify it.
Correct.
Okay,
A
that is
great example for this is exactly how Redis does authentication. So Redis pay, when you create a connection, you give this command called auth.
Okay.
And uspe you give the password. I want to connect to this database. So I am this user with this password. So Redis ka auth happens on the first time when you connect.
All right. Okay.
Try that out. Chala. Yeah, Pradhan?
Something again a bit my topic. So I was just wondering, let's say the same chat application, but instead of Telegram, WhatsApp, we have something like a Snapchat where it doesn't store the data. So DB ka kaam to aaya nahi.
So there would be a small buffer that has to be there.
So in that case, let's say I would only remove that from the Redis thing once the user has read it, right?
with correct. Once the user has read it, we
has
will
read it, that
remove.
then only. So in what cases, like, could there be a problem? Because let's say,
think about it. Both cases. You can only think about it. What would be the problem?
okay.
See, what could go wrong? How will you ensure that every user has read the message to whom it is broadcasted? So you need an acknowledgement framework, right? Where you are getting acknowledgement from all the users.
Got it. Yeah.
Unless you get from all of them, then you're not deleting it. Okay. But then there has to be one TTL associated to the message. You can't wait infinitely. Yeah, I'll get an acknowledgement because let's say some user is never logged into WhatsApp.
Yeah.
Now what? Right? These are edge cases that you need to know. So everything has to have a TTL. Let's say I'll max store it for 7 days. In 7 days, just pada nahi pada gaya. This is very similar to WhatsApp stories. So now next time someone asks you to design WhatsApp stories, this is exactly how you do it.
Yeah.
Correct? Because WhatsApp stories where people have seen is seen. Nahi seen to delete after 24
it's
hours.
gone. Yeah.
Something similar to that.
Yeah. Thanks.
So many systems. Yeah, answer.
What will happen if Redis node goes down? Like we don't have persistence or a
nice. What would happen? You say?
We can have a replica for it, and we can store it in sync.
See, we are not having any data in Redis, so it's okay for Redis to go down because
Yeah,
we'll
but
not be losing out on any data.
But those chats will be lost. Like we won't be
Those
knowing.
TCP connections would be killed. Chats will not be lost. TCP connections would be killed. So what you would have to do is number one, the approach that you said, have a standby. So let's say for a few seconds that other standby comes in, all the servers will again create connection to this new Redis that comes up. Correct. Approach number two, have a backup policy. In your code, what you will do is, if I'm not getting, if I did not, if my Redis connection failed, until my Redis connection comes back, use this message broker as my buffer pool.
Okay.
Think about it. You are using that message broker as a buffer pool because your Redis is not working. You are buffering the message in this broker. And once the Redis connection is up, you are first draining everything out from this SQS and then basically sending message from this main Redis connection because now that it is up.
So one case can be there, like production rate is higher, producer rate is higher, and consumer rate is higher, and producer
consumer rate is lower, producer rate is higher. More messages being sent to you versus the speed at which it is consumed.
So Redis is producing at a low speed as compared to it is getting the messages. In that case, it will be having some messages in the queue itself, in the Redis itself. So those messages
Redis will not
lost.
accept messages to be sent to it unless it is broadcasted. So that will not be a problem.
Okay.
So since it is TCP connections, since we are using TCP connections, once the data is flushed, then the next data is flushed, the next data is flushed. Right? So your servers might choke up. Let's say one user is sending a lot of message, then that when server ka Redis ka connection might choke up. That's where you'd want to have the partitioning thing. Let's move this user to another place and do that thing, or add or basically prevent this user from posting again. So that is where rate limiting comes into the picture, where you would rate limit the number of messages a user can send in some time. Every message application has that.
Okay, got it.
Yes, Sukata?
I had a question about, say, the thundering herd problem, and say all of your clients suddenly, there's an internet outage in a region, and there's a lot of writes that happen, and then the internet is restored, and all of your clients come back online at the same time. How do we prevent our local servers from becoming overwhelmed with the amount of read traffic and like sort of synchronization? So imagine all the servers in region India go down, they come back online, they all connect to the same Redis cluster. They're all reading. There's a huge amount of throughput going through. How do we prevent?
The answer is very simple. What you can do is a very, very, very hacky thing. You add a random time sleep when the server starts. Let's say somewhere between 1 to 5 seconds. Pick a random time delay, a pseudo time delay, so that not everyone tries to connect to the Redis at the same time. That has actually helped us solve a lot of problems. Whenever our API server starts off, we have a random time delay between 1 to 10 seconds.
I see. And I'm guessing there's some kind of like jitter so that
Yeah,
different servers
exactly.
start
That's the
different
right
times.
one.
Yeah.
Exactly, that's the right one. So something that we
Got
have
it.
studied in the networking course, where we have to add a jitter before retrying. Otherwise, if a request, you make a request and that fails and you immediately retry, and this happens a lot with a lot of your consumers, what would happen is your main server is getting choked because of getting so much of request. So to solve this, not to have a lot of your consumers poll at the same time, you add a jitter in between, some random delay. When you add a random delay, then it would retry. So it would basically, hopefully, it would uniformly pan the request out in the duration of that 10 seconds. And this 10 seconds depends on the number of people who are trying to make that connection. So in our case, it's about 50 servers. So 10 seconds is more than enough. 5 servers trying to make one connection.
Got it. And these, I'm guessing you would have two layers of jitter, one at the client, like let's say as a mobile app, and one at the server level.
Yep.
Got it. Yes.
Yeah, Sarthak?
So let's say we have a use case like showing someone is online, or whether like showing someone is typing, like we have it in WhatsApp. So in that case, I'm assuming we would send events to the same Redis, and that event would be forwarded to clients and they can show it.
Same way, yeah, same way.
Oh, thanks.
Yeah, Brancho?
So Arpit, so this in this case, all of these clients are trying to do a GET request, right? And it's easy because we can put a consumer who's they can read from this consumer.
Yeah.
I just wanted to draw a parallel this to the alerting system where the event needs to be pushed, right? And the clients needs to showcase that. So in that case, like what exactly is this? How do we push that, and how do we relate to the client, which is reading all those alerts?
Event is pushed as in event from what? Let's say my server is down. Let's say one of my service is down, and that event needs to be pushed somewhere. And
any of the telemetric in the sense, right? Like when we are reading a data on a time series basis and so on, and there is some event, some abnormality that you wanted to read upon. So you have to, like, are you doing a constant polling for doing it, or is it like whenever the events happen, it just get pushed to the system and then it's get
No. So we would have some database to store our time series data in which real time, in which let's say every 1 second we are doing anomaly detection. Once you have detected an anomaly, we push it to a queue. In general, I have not built this, but basically out of my intuition, I can say how we can build this system. So obviously we would have to have something that was finding if there is an anomaly in the system. Once we've detected an anomaly, we can push it to a queue, and from that we can decide to basically fan out to to basically do whatever action we want, either to do an alerting and do a fan out to all the people who have subscribed to that alert, right? But then that has to go through that queue.
And this push is basically happening from like what system is actually pushing it?
There will be one time series database, some API server which is sitting in between running this anomaly detection job once every, let's say, 1 minute. And once it detects it, it would let's say send a message in SQS queue.
I see. So is that how in principle CloudWatch sort of thing works?
Most probably वैसे ही होता होगा. There is no other architecture. Basically someone has to fire a query to detect anomaly.
Right. Yep.
And then basically that person or that code needs to, once it has detected anomaly, that is the one who needs to act upon it. Right? And that act has about what to push a message in SQS and so that other can consume.
Understood.
Okay. Yeah, Costa?
So if the Kafka server goes down and like
writes are failed.
But like the Kafka server won't return to the first server till it's returned to all other servers, right? API servers. So what if it writes to some of the some of the other servers, but not all of them? So in that case, the message will be delivered to like a subset of the users, right?
Kafka server, I think, where are you putting Kafka server here?
Sorry, the
Redis.
message queue. Sorry, the Redis one. So
Redis one,
yeah,
that is the problem. That is the problem that you have to live with. Yeah.
Okay, so but like, are there any workarounds for things like this? Because in WhatsApp, we wouldn't want a message to go to just
What
one
would you
subset
do?
of.
Chalo, let me ask, what would you do?
I just have no idea at this point.
Arey, think, ra, think.
Hey, can you repeat that question?
See, if the Redis message queue goes down, right, it won't tell server one that the write is completed, but it could have completed. So S1 is writing to Redis queue, right? So like Redis, which you're using as a queue in a way. So S1 will write. Suppose S2 and S3 get the message, but S4 doesn't get it. In that case, EFGH get the message. Like suppose A is writing it, right? So it doesn't know that the write has completed or failed, or it might assume it has failed, but it could have partially succeeded.
Now, so
Right.
let me put it a simpler way. A has published a message. S1 has put a message in Redis saying if S2, S3, S4 go ahead and broadcast it. The message was received by S2 and S3, but not S4. Through this, what it means is the broadcast will happen to A, B, C, D, E, F, G, H, I, J, K, L. But since S4 never received the message over TCP from Redis, because at that point Redis went down, so PQ, so basically MNOP will not get that message. Correct, Kaustubh?
Yeah.
So something like then a receive acknowledgement is what would be needed, right? Between the servers.
That's really hard to build.
Fair.
But if your Redis goes down, there is a much simpler way to handle this thing, which almost every single system does. See, because this kind of outage is very rare. You would not want to have acknowledgement being sent by every time when this thing happens. If an event is rare, right, you would not want to build a regular solution for that. You would have to treat it as an exception and then build a very simple hack to fix it. What would you do, Kaustubh?
Do S2, S3, S4 get a notification that Redis went down?
They would get to know, na?
Okay, then they can just call back the messages like S2 and S3.
But which message to call back? How would it know which message to call back?
Okay, that's
the problem, na?
Yeah.
When the Redis comes back up again, the client that went down gets back the updated message and then reorders it on the client side.
How
Can
would
that
they?
be done?
How would the client get the updated message?
No, when Redis comes back up again, he kind of like.
But then A will never resend the message again, na? Because A ka job is done. A sent a message, server will publish the message on Redis.
The DB is there for the persistence, right? So can we just check with the persistence current state with the DB, get out all the extra messages, and then reorder?
Or else we can broadcast the messages one more time, and we can do deduplication.
How many times would you do it?
Side.
How many times would you do the broadcast message? How will you know which message to broadcast? Which means now S1 also needs to keep a buffer of messages that it received when Redis got down and in general maintain that.
I mean, there is something like deduplication, like
very hard solution. Very hard solution.
Okay.
Think simple. Think simple.
S1 gets an acknowledgement from Redis if it went down, right? Like if it went down, the message, like it wouldn't get back.
Redis would not say Redis. It would just give you connection error. Yes,
Okay.
will get a connection error.
Okay, so S1 can keep on retrying. S2, S3, S4.
But S1 already sent a message. Why would it retry?
But if it failed, right? Like
it would not know that it would not know that S2, S3 got it, but S4 did not.
But it would know that Redis failed, right? So it can resend it, and on S2,
which message? Let's say S1 sent. That's a wrong solution. Think about it. What's the problem with this option? Think. Think.
Offset. So it should maintain some kind of data structure that okay, it has been broadcasted, and one is left.
Very bad way to do it.
Is there any method of offset? Because Kafka does have, right? It knows that this consumer had this offset. Right? So does it have also? I'm not sure because I'm not used PubSub.
No. You guys are making such complex things, such simple thing complex. See, if this event is so rare, what you can do is let all the clients poll the main DB to get if any messages that it has not received. Let's say every time, but for your system, let's say how long would your Redis or how long can you afford your Redis to go down? If you're building a real-time chat, you cannot afford a Redis to go down for more than, let's say, 5 minutes. Okay, so given that assumption that your SLA, that your team has said that my Redis, if it goes down, another Redis will come up in 5 minutes. Now what would happen is the max window of your messages of you not receiving that message is what? 5 minutes. Correct. Now what if your database has an API expose that gives you all the messages that you have received or you should have received in last 5 minutes? And you make a call to see if you have that you have all the messages that you need or not. Correct. Instead of building that complex architecture for your servers to do that retry, it is simpler for your mobile devices or for your clients to do that retry with your main database, not with Redis, with the main database. कि भाई, in case I've missed anything, just वापस दे दो मेरे को. Because main database is your source of truth. Right? So in any case, due to any reason, any broadcast failed ever to a client, to a certain user, let's say P or Q or M or N, that once a while would do that job. Let's say once every 5 minutes, one API call goes to the database that gives all the messages that I should have received. Not the message, but at least message IDs. Right? All the message IDs that I should have received in 5 minutes. How many messages do you receive in 5 minutes? 100? Max 100, like 150, like 1000, right? 1000 message IDs ka hash bhi if you send it, that's also very lean network part. Right? So approaches like this are actually in place. So once a while you would see WhatsApp or if you open WhatsApp web also, na, usme bhi you can see this thing that once a while WhatsApp keeps that poll message that, okay, I've received all the messages till now. Check that thing. I've actually checked that. So I've found this kind of solution. So let these complexities be offboarded to your end user to poll from the main source of truth to check key. Okay, I want to ensure that once every 5 minutes, I want to ensure that I have all the messages that I should have. Right? Because building that complexities around this server failed and then this server needs to retry, then this server needs to have a temporary database and another server needs to have something. That's really hard to do. Chalo, final question before we wrap. Yeah, Anshul.
So basically, in this case, we will be storing which servers have processed what messages, like
No,
S3.
not servers. Client users, actual ABCD, like me. My WhatsApp would go and say in last 5 minutes, give me all the messages that I should have received.
Okay.
Every once in a while, I'll do that correction check. In case I've missed some message, I need to get that message.
Got it.
Not the server, the end user. Okay.
But then the server would have to have a logic wherein what was the last message that I sent. Right?
That's where Kaustubh's first solution around this thing, around sequence
Append
numbers
log.
and all would come in very handy.
Log appending, right?
Yeah, append log, sequence numbers, and this is something that Dropbox actually uses that we will be discussing. Okay, how to do this part. How do we design a database that would help us query this thing efficiently? But this is too early to discuss that because it requires few more things before we jump into that. So mostly around 6th, 7th week, we'll be discussing this very solution on how do we achieve this. You guys are running a little early.
And
but
probably we coming with all such sorts of difficult or complex solutions, we forgot that there is a main DB. That's
exactly. There are so many components out there. See, that's what happens with systems. When you have massive systems, you might forget this like this, like and it's that. Chal, nice. Chal, again 3 hours back to back. I could not expect. This is really fun. Chalo. Thanks guys for joining in.
Thank you.
See you.
It was a
next
great
week.
session.
Yeah. So, bye-bye.
Thanks. Bye, folks.
Bye, folks.
Thank you, everyone.
Thanks everyone. Bye.